numerical problems, second part 2. So we have seen up to 100 in the last part. Now we'll start from 101. In the multiplication of 107.88 and 0.610, the correct answer is, so when you multiply two figures, we will see the significant figures. Significant figures in second number is 3, first number is 5. So we have to give only 3 significant figures. We consider only 3 significant figures. When we multiply, okay, we are getting 65.807 is the big number we are getting, but we take only 3 significant figures, so we will get 65.88. Next, 1 or 2, subtract 0.2 kilogram from 34 kg. The result in terms of proper significant figures is, for 34 minus 0.2 will get 33.8. So when subtracted, we have to see so when it's subtracted, we have to see the number of decimals. So in 34 kg there is no decimals, therefore there is no decimal required. So without decimal we have to write, okay, we'll round it off without decimal. So we will get 34. Okay, the answer is 34. Okay, now 97.5 is divided by 2.54. The correct result in terms of significant figures is, so when 97.5 is divided by 2.54, what we are getting is 38.397. But actually significant figures is, the second figure is 3 and the first figure is 4. Therefore we have to take only 3 significant digit, so we will get actually 38.4 because it is rounding off. The next digit is 9, therefore we round it off to 38.4. Now 9.8 is divided by 9.3. The current result should be written as, so when 9.8 is divided by 9.3, we will get 1.538. So this one, sorry, we will get 1.0537. So maximum 2 significant figures is required. Therefore it will be rounded off to 1.0. Since actually it is 0.5 and the adjacent, the preceding figure is 0, is even, so we will write 1.0. Since 0 is even, we will write 1.0. But if it were odd, we should have added, we should have increased it by 1. But since 0 is even, we will write 1.0. Next one, the dimensions of electric field E is equal to F by Q0 is equal to 1 by 4 pi epsilon 0, okay, into Q by R square. So 1 by 4 pi epsilon 0 R square into Q. So it is actually E is equal to F by Q. Okay. So where F is the electric force experienced by test charge, Q0 is the magnitude of positive test charge. Now then E is equal to F by Q. F by is actually ml t raised to minus 2, Q is 80. So what we will get? We will get ml t raised to minus 3 a raised to minus 1. So the unit will be Newton per coulomb or volt per meter, or Newton per coulomb or volt per meter. Okay. Next is find the dimensions of physical quantities. Permittivity. We have to find epsilon 0 permittivity. So we know that F is equal to 1 by 4 pi epsilon 0 R square into Q1 Q2. So epsilon 0 is equal to 1 by 4 pi of R square into Q1 Q2 is equal to 1 by 4 pi into ml t raised to minus 2 into L square, okay, into AT the whole square, Q1 Q2 charge, ampere into 10, AT. So it is A square T square divided by ml cube T raised to minus 2. Okay, is equal to m raised to minus 1, L raised to minus 3, T raised to 4, A square. Okay. Next is permeability. So we know permeability mu 0 is equal to 2 pi RF by I1 I2L. Okay. So ml T raised to minus 2 into L R. For R it is L. This is for force divided by I1 I2 mean AT the whole square into L is L. L get cancels. Okay. Now what you will get? ml T raised to minus 4 A raised to minus 2. So 1 second. T raised to minus 2. ml T raised to minus 2 divided by L into I1 I2. There is no T square here. Actually, it is not charge, it is I. That's the mistake we made. This is actually A square only. Okay, A square only. So it is T raised to minus 2 only here. Okay, this will not be what we have written actually instead of I have written actually AT. Okay, it is actually A square only. AT is nothing but charge. It is only I, the field is A square. So ml T raised to minus 2, A raised to minus 2. Okay, that is the answer. Next one is capacitance. Capacitance is equal to Q by V. So AT by V is W by Q. Okay. So AT into AT by W is M square L square T raised to minus 2. Okay. Therefore, M raised to minus 2, L raised to minus 2, T raised to 4, A square. Okay. Next one is impedance. Impedance is nothing but resistance. It's equal to resistance only. Resistance. So resistance will be V by I. Okay. So V is equal to W by Q. Okay. I. So W is ml square T raised to minus 2. Q is AT into A. So it will be M L square T raised to minus 3 A raised to minus 2. So impedance is ml square T raised to minus 3 A raised to minus 2. Okay. Next one. Next one is conductance. Conductance. What is conductance? Conductance is equal to 1 by resistance. Therefore, it is m raised to minus 1, L raised to minus 3, so sorry, minus 2, T raised to 3, A square. This is the reverse of the reciprocal of this value. Now, current density. Current density is equal to I by A. So, it is I by A is I by area, current by area. So, it is A L raised to minus 2. Now, conductivity. Conductivity is equal to, first we'll say what is rho, specific resistance. Specific resistance, finding resistance, we know that R is equal to rho L by A, which implies rho is equal to R into A by L. So R, just now we have found out R is equal to impedance is M L square T raised to minus 3 A raised to minus 2. Okay, into A is L square divided by L. L is L again. Okay, so what we will get? We will get, so L square, so resistance is ML square T raised to minus 3 A raised to minus 2 into RA. A is L square by L. So one L will get cancelled. So we will get actually M L cube T raised to minus 3 A raised to minus 2. Okay. So conductivity is 1 by resistivity. So we will get M raised to minus 1 L raised to minus 3 T cube A square. This is conductivity. 1 by specific resistance is conductivity. Next is electric field intensity. Electric field intensity. Electric field intensity is equal to F by Q. Already we found out this. Electric field intensity F by Q is MLT raised to minus 2 divided by AT. Okay, so MLT raised to minus 3 A raised to minus 1. Now power. Power is equal to work by time is equal to ML square T raised to minus 2 by time is actually ML square T raised to minus 3. Okay, that is power. Potential difference, V, potential difference is equal to V is equal to, W by Q. Okay, W by Q is actually ML square T raised to minus 2 by AT. So we will get M L square T raised to minus 3 A raised to minus 1. Energy density. Energy density. Energy density is actually energy per unit volume. So energy per volume is equal to M L square T raised to minus 2 by volume. Volume is L cube. So M L raised to minus 1 T raised to minus 2. Next is magnetic flux density. Magnetic flux density. Magnetic flux density. Okay, we know that F is equal to BIL sin theta. Okay, which implies magnetic flux density B is equal to F by IL sin theta. So sin theta has no dimensions. Therefore, ML T raised to minus 2 by A into L. IL is A into L. Then LL get cancels. Therefore, M L raised to minus 2 A raised to minus 1. Sorry, M T raised to minus 2. M T raised to minus 2 A raised to minus 1. T raised to minus 2 A raised to minus 1. Okay. Now, next question is 107. EMLG denote E is equal to energy, G is equal to gravitational constant, then M is equal to mass, then L is equal to angular moment. Okay. Then what are the dimensions of E? L square, M raised to 5, G square. Okay, this is what we want to find out. So E, we know, is energy is equal to ML square T raised to minus 2. Okay. Then L square, we know, it is EL square. L is L is actually EML. L is angular momentum. Angular momentum is equal to I omega. Okay. I is equal to linear momentum is equal to M L square T raised to minus 1. Okay, this ML square T raised to minus 1. Angular momentum is ML square T raised to minus 1. Then G, for finding out G, F is equal to G M1 M2 by R square. So G is equal to FR square by M1 M2 is equal to ML T raised to minus 2 into L square by M square, which implies M raised to minus 1 L cube T raised to minus 2. So G is equal to M raised to minus 1 L cube T raised to minus 2. Okay. Now what is E L square by M raised to 5? G square is equal to E, we know, ML square T raised to minus 2 into L square divided by M raised to 5. G square is actually M raised to minus 2 L raised to 6 T raised to 4 T raised to minus 4 is equal to M raised to M cube M square M cube M raised to 5 M raised to minus 2. Okay. Now M cube. Okay. Then L raised to 6 L raised to 6 L raised to, okay, I mean top we will get, let's see, E L square. E is equal to energy ML square T raised to minus 2. So ML square T raised to minus 2 into L square is not, this is wrong, this is not, L is not distance here, L is I omega, therefore that is what the mistake we made is actually M L square T raised to minus 1 the whole square. So it is, so what we will get, ML square T raised to minus 2 into M square L raised to 4 T raised to minus 2. Okay. Divided by M cube L raised to 6 T raised to minus 4 is equal to M and M square M cube, okay, L raised to 6 T raised to minus 4 divided by M cube L raised to 6 T raised to minus 4. That means M cube L raised to 6 T raised to minus 4 divided by M cube L raised to 6 T raised to minus 4 is equal to M raised to 0 L raised to 0 T raised to 0. That is dimension. That's not dimension for this. Okay, there is no dimension for this expression. ML square. Okay. But then EL square divided by M raised to 5 G square. There is no dimension for this. Okay. Next one. The value of multiplication 3.124 into 4.576 to 3 significant figures. So it is multiplied 14.2954. 3 significant digit means actually 14 point, it will be 14.3. 14.3. The value of expression 7.13 into 21.54 will be 415.3. Correct to 3 significant figures. Okay, when you calculate this, the figure you are getting is actually 0.3698. So 3 decimal if it is corrected, it will be 3.70 because 9 will become 10. So 8 means the next, when you take 3 decimal digits, since it is more than 6, 9 will become 10, then it will come to 7 here. Therefore, it is 0.370. Next one, the radius of a thin wire is 0.16 millimeter. The area of cross section, taking significant figures into consideration in square millimeter, is, so area of cross section. Okay. Radius is given. So area quotient will be actually pi r square. So when we calculate this, you will get actually 3.14 into 0.16 into 0.16. Okay. So you will get 0.080384 something you will get. So since actually the significant digit is 2, you have to round off to 0.08. Okay. Next one is ml square t raised to minus 2 are the dimensions of work. That everybody knows. Work, energy, couple. All are having the same couple. Torque, couple is nothing but torque. For work, couple, torque, and all of having the same dimension. If the unit of length and force are increased by 4 times, the unit of energy is increased by. So energy, we know, force into length or distance, whatever. So what happened? If the unit of length and force is by 4, mean the 4 will become 4m, this length will become 4l. It will be 16 f into l, means 16 times it will increase. 16 times it will increase. These are all simple questions only. What we will consider. Next one. ml raised to minus 1 to raised to minus 2 is the dimensions of. So m l raised to minus 1 t raised to minus 2 is the dimensions of. What is this dimension? This is actually dimensions of pressure. Pressure is equal to F by A is equal to m l raised ml t raised to minus 2 divided by L square. Therefore, it's ml raised to 1 t raised to minus 2. It is actually pressure, then stress. Okay, pressure, stress, then yeah, all these things will come. This is the dimension of stress here. Actually, stress is given. We will take stress. Okay. Now the number of significant figures in 114. We have considered 114 here. So 11.118 into 11.118 into 10 raised to minus 3. What are number of significant figures? The number of significant figures actually this we will not consider. Okay, the power, I mean 10 to the power we will not consider at all. So we'll consider only this, and there are actually 5 significant figures. Now 4 lengths are measured: 18.425, 7.245, I mean 215.4, 10.377, 3.571. Take significant figures into account the sum of the length. So when we add up all this thing together, what we will get? 41.3921. So in the 4 figures given, which one is having the least significant figure? It is actually 3. Therefore, this we have to round off to 3 significant figure, then it will come 41.4. Next, taking into account the significant figures, the product of 109.832 and 0.6107 should be. So the significant figures is actually 4. Second one 0.6107. There are 4 significant figures. Therefore, it should be rounded off to 4 significant figures. Answer we are getting is actually 67.0744. When it is rounded off to 4, we will get 67.07. 14.28 is divided by 0.714. The answer should be, well, the significant figures is 3. Therefore, when we divide it, we will get the answer is 20. So 20.0. Then only there will be 3 significant figures. Next one, the position of particle moving along the y-axis given by, so position is given by y is equal to at square minus bt cube, where y is measured in meters, y is in distance, t is in seconds. So dimensions of b, we have to find out the dimensions of b. Since actually y is distance, okay, then y, the dimension of y should be equal to dimension of vt cube. Vt cube. So which implies b is equal to vt cube means actually this actually L is equal to b t cube. So b is equal to L divided by t cube is equal to Lt raised to minus 3. So the answer is Lt raised to minus 3. Okay. Next one. Rho is the mean density of Earth. So rho is density, then r is radius, okay. Then r is radius. Rho density means m L raised to minus 3, okay, mass by volume. R means L, length, okay. Then g is acceleration due to gravity. G acceleration due to gravity means is acceleration, Lt raised to minus 2. And g is the gravitational constant. Gravitational constant, we know, g is equal to f r square by m1 m2 is equal to ml raised to minus 2 into L square divided by m square. It will give m raised to minus 1, t raised to minus 2, L cube, okay, m L cube, t raised to minus 2. M raised to minus 1, L cube, t raised to minus 2. Okay, g is equal to m raised to minus 1, L cube, t raised to minus 2. Okay, now the question is, if rho is the mean density for the r is radius, g is the acceleration due to gravity, and g is the gravitational constant, on the basis of dimensional consistency, the correct expression. So what we will do, we have to find out. Now we know that rho is proportional to r raised to a, then g raised to b. It is actually dependent on these 3 quantities, g raised to c. So g we know ml raised to minus 3. Okay, it's proportional to or is equal to. You can do it is equal to k also you can write, or proportional itself you can write. So r is L raised to a, then g is Lt raised to minus 2 raised to b. Then g is actually m raised to minus 1, L cube, t raised to minus 2 raised to c. Okay, so when you solve it, you will get m raised to minus c, L raised to a plus b plus 3c, t raised to minus 2b minus 2c. So which implies, so you can equate these two. Okay, then you equate left hand side and right hand side. Minus c is equal to 1, which implies c is equal to minus 1. Okay, that is first thing. Second thing is actually minus 2b minus 2c is equal to 0, which implies b plus c we have received as minus 1, b minus 1 is equal to 0, so b is equal to 1. B is equal to 1, c is to minus 1. Now a plus b plus 3c is equal to minus 3. So it's minus, which implies a plus 1 minus 3 is equal to minus 3. Therefore a minus 2 is equal to minus 3. Therefore a is equal to minus 1. A is equal to minus 1. Now therefore the equation rho is proportional to r raised to a, g raised to b, and capital G raised to c is r raised to 1, g raised to 1, capital G raised to minus 1. So rg by capital G. So let us see where rg by capital G is coming. Rg by capital G is coming in third one. Sorry. R into small g sorry, this r raised to minus 1. This is r raised to minus 1. A is equal to a is equal to minus 1. Therefore, r raised to minus 1 is actually, therefore, g by small rg. R and g will go down. Therefore, the answer should be third one, 3 by 4. 3 by 4 pi will not be considered. It is, since it is the constants. Therefore, g divided by rg. Rg will come in the denominator, g will come in the numerator. Therefore, it should be g by small r into capital G. Okay. This is the expression, final expression. Okay. Next one is match the following list. So A, B, C, D are given. List 1 is angular momentum, torque, stress, pressure gradient. So angular momentum, we will take the angular momentum. We know angular momentum is equal to I omega. I is the moment of inertia. So it's m L square T raised to minus 1. Okay. So m L square T raised to minus 1 is 3. Okay. Then the angular momentum A3 is coming actually the second one only. So that will be the answer. Even then we will check actually all the things. Anyway, this is coming actually to, okay, A3. Then torque is nothing but work. Therefore, m L square T raised to minus 2. So torque B m L square T raised to minus 2 B1. Sorry, B2. Okay, that's also correct. This is also coming to 2. Then stress is actually pressure, force by area. That is m L raised to minus 1 T raised to minus 2. F by area. F is m L T raised to minus 2 divided by L square. That is m L raised to minus 1 T raised to minus 2. That's also correct. Then pressure gradient is pressure by distance. Therefore, this is actually pressure is we receive stress equal to pressure. Therefore, m L raised to minus 1 T raised to minus 2 by L. Therefore, m L raised to minus 2 T raised to minus 2. Okay. So L raised to minus 2 T raised to minus 2. Okay. So it is actually A3, B2, C4 and D2. Again, it is actually that 122. 2 is the correct answer. Okay. Next one. Next one is match the following again. Here, list 1 gives surface tension. Surface tension, we know surface tension. What is surface tension? Is actually tension by length or force by length. Okay, tension by length. Nothing but force by length. Therefore, m L T raised to minus 2 by L. So both will get cancelled. Is equal to m T raised to minus 2. Okay, surface tension. So let us see where it is coming. Okay, but actually we have to find out the unit. Okay, so tension by length. So it is m kilogram second raised to minus 2. Okay, mt raised to minus 2. Next is pressure. Pressure is equal to force by area. That is m L raised to minus 1 T raised to minus 2. Okay, that is, it is kilogram meter raised to minus 1 second raised to minus 2. Yeah, this is actually 3. It will come in the 3 kilogram meter minus 1 second raised to minus 1. Okay, next is viscosity. Viscosity eta is equal to F by a dv by dx. Okay, dv by dx is the velocity gradient. F we know ml t raised to minus 2 divided by L square into dv by dx. Velocity gradient is Lt raised to minus 1 by L. So t raised to minus 1. So it will be m L raised to minus 1 t raised to minus 1. So 6 kilogram meter raised to minus 1 second raised to minus 1. Okay. Okay. First one. This first. Okay. Next is impulse. Impulse. Impulse is actually force into time. Okay. Impulse is force into time. So ml t raised to minus 2 into t is equal to ml t raised to minus 1. So kilogram meter t raised to minus 1 is second raised to minus 1. Kilogram meter second raised to minus 1. It will be 2. Okay, now the list matches. So the answer is 1. A4, B3, B3, C1, D2. Okay. Next. Next one is, given that y is equal to a cos t by p minus q by x, qx, but t is time in seconds, x distance in meter, which of the following statement is true? Unit t, same dimension, unit of t is same dimension as p. What is the dimension of p that we have to find out? Because cos t by p by qx has no dimensions. Therefore, t by p is equal to q by x. Okay. So x is having dimension of length. Okay. So to make this dimensionless, if x is having dimension of length, q also should have dimension of length. Then only it will become dimensionless. So p should have dimension of t. Then only it will have. Okay, this is not q by x, it is qx. So if x is equal to x, the dimension of x is L, therefore q should be L raised to minus 1. So q should be L raised to minus 1. Then only L into L raised to minus 1 will become dimensionless. Then t by p should have the dimension of t. Then only it will be dimensionless. Okay. So unit of t is same as p. That is the correct answer. Okay. Next one. Which of the 5 physical parameters have same dimensions? So energy density, refractive index. Which of the following 5 physical parameters have the same dimensions? So energy density, refractive index. So energy density, we know that energy by volume. Energy by volume. It is actually m L square raised to minus 2 divided by L cube, which will give m L raised to minus 1 L raised to minus 2. So if you take refractive index, it is no dimension. Refractive index is a ratio. Okay, ratio, therefore it does not have a dimension. It is the ratio of the speed of light in vacuum to the speed of light in the given medium. So it is the ratio of 2 velocities. Okay, then when it is dimensionless. Again, dielectric constant also is the ratio of 2 permittivities. So since both the permittivities having same dimensions, actually it is also dimensionless. Third one is actually Young's modulus. So Young's modulus is actually equal to stress by strain. So strain, since it is the ratio of length delta L by L or DL by L mean actually elongation by length. So that is dimensional length. So it is the ratio of the similar, two quantities having similar dimensions. Okay, both having L, both are L distances. Therefore, it is dimensionless, strange dimensionless. Stress is actually is a force by area pressure only. So stress is actually M L raised to minus 2 T raised to minus 2. Okay. So stress and mg density are having the same dimensions anyway. ML L raised to T raised to minus 2. No, not stress. It is the Young's modulus. Young's modulus and this mg per volume is having same dimension, same as stress and pressure. Both, they're all having the same dimensions. Then it is in magnetic field, we don't have to consider it at all because magnetic field is having a different dimensions. Therefore, you don't have to consider it here. So we know, if you want to find out, actually we know V is equal to F by QB. Okay, sin theta is having no dimension, it is F by QB sin theta. F is equal to ML T raised to minus 2, QB is equal to A T, V is equal to L T raised to minus 1. Okay, it's having the dimension velocity. So L T raised to minus 1 goes, then L and L will get cancelled, then it is M T raised to minus 2, A raised to minus 1. Okay. Okay. That's a small mistake here. What is written? ML T raised to minus 2 F divided by QAT L T raised to minus 1. ATN L T raised to minus 1 will get cancelled. L and L will get cancelled. Then A raised to minus, then it is actually M T raised to minus 2 A raised to minus 1. So see, energy density and Young's modulus is having the same dimensions. Now, this thing we have already done. EML, GR, the energy mass and momentum, absolute constant. Okay, we already done this. So the answer is D angle, dimensionless. Dimensionless means it's an angle only. Okay. Even that, next one. Even that, integral of dx by square root of 2x minus x square, okay, is equal to A raised to n sin inverse x minus a by a, where a is constant, okay, constant, then x is distance only, distance. It's not mentioned here, but it is distance only. Okay, now what happens? Since sin inverse x minus a by a is dimensionless, what happens? X is equal to a. Okay. So a is a constant. So x is a constant and x is equal to a. So then if it is L, then sin inverse x minus a by a is equal to sin inverse L by L. So it will become dimensionless. Now what happens? Integral of dx by square root of 2 ax minus s square is equal to L by square root of L square. Again, is equal to L by L. It is dimensionless. Okay. So both sides, if you want to get dimensionless, so it should be a raised to n should be 1. For a raised to n should be 1 means actually n should be equal to 0. Then only it can become 1. Okay. So n should be 0. Next one. Assuming that the mass m of the largest stone that can be moved by flowing river depends on the velocity v of water. So we say mass depends on velocity of water, density, then acceleration due to gravity g raised to c. Then m raised to 1 is equal to LT raised to minus 1 velocity raised to a. Rho is actually, we know mass by volume, m raised to 3 minus m raised to b. Then g is acceleration due to gravity is the velocity by time or distance by time square, the LT raised to minus 2, okay, raised to c. So when we substitute, this is actually m raised to 1, L raised to 0, T raised to 0, okay. So what we will get? We will get m raised to b, L raised to a minus 3b plus c, t raised to minus a minus 2c. Okay, thus b is equal to 1, a minus 3b plus c is equal to 0. Okay, then thus a plus c is equal to 3, minus a minus 2c is equal to 0. Thus it implies minus c is equal to 3 or c is equal to minus 3. A is equal to 6. Okay, hence the power of v. So what we will write? M is equal to v raised to 6. Okay, rho raised to b. B means 1. Then t raised, not g raised to minus 3. So the power of b is 6. The answer is 6. V raised to 6. The position of x of a particle at time t is given by x is equal to v0 by a 1 minus e raised to minus at. Okay, so v0 is a constant and the a is greater than 0. Okay, so what are the dimensions of a? The question is, what is dimension of v0? So we know that 1 minus e raised to minus at or e raised to minus at is having no dimensions. So e raised to t having no dimension means, which means a should have dimension of t raised to minus 1. So dimension of a is equal to t raised to minus 1. Okay. So v0, we know that x is equal to L. Okay. This is the dimension of distance. So it should, the same dimension should have for v0 by a also, since 1 minus e raised to minus 8 is dimensionless. So v0 by 8 is equal to v0 is lt raised to minus 1. So here will be t raised to minus 1. Okay, then it will have the same dimensions. Or we will do other way. Then it should, since actually v0 will have what dimension we will find out anyway, a is t raised to minus 1. Then since it should have the same L, the same dimension of the left hand side x is having dimension L. To get L to be added here. Therefore, then t raised to 1 will get cancelled. Therefore, then the velocity of v0 will be lt raised to minus 1 velocity. The dimension of v will be velocity. So the answer is actually A dimension is t raised to minus 1 and B0 dimension is LT raised to minus 1. That is the answer. Next one. If the dimensions of critical velocity Vc of a liquid flowing through tube is expressed as n raised to x rho raised to y r raised to z, where so not n, it's eta, rho and r are coefficient of viscosity of liquid, density of liquid, and radius. Then the values of x, y, z are. So it's given dimension of critical velocity b. B is proportional to n raised eta raised to x, rho raised to y, r raised to z. So the dimension of x, y, z is to be found. B's critical velocity means LT raised to minus 1. Proportion to eta. Eta is equal to, so we know that F is equal to viscous force, F is equal to eta A dv by dx, where dv by dx is the velocity gradient. Okay, so from this eta is equal to F by A dv by dx is equal to mlt raised to minus 2 divided by L square into LT raised to minus 1 by L. So T raised to minus 1. Then actually what you will get M L raised to minus 1 T raised to minus 1. Okay, so you will get eta. Then rho, anyway we know rho is equal to M L raised to minus 3. Okay, so then R is the radius, right? R is the radius. So it is L only. R is equal to L. So here we will get eta M L raised to minus 1 T raised to minus 1 the whole raised to x, rho M L raised to minus 3 whole raised to y here. This is L raised to z. Okay. So when you are solving it, so you will get x plus y is equal to 0 minus x minus 3y plus z is equal to 1, then minus x is equal to minus 1, which implies x is equal to 1, then y is equal to 1. When x is equal to 1, y is equal to 1, x plus y is equal to y is minus 1, x plus y is equal to 0. Okay, then minus x minus 3y plus z is equal to 1, thus 1 plus 3 plus z1. Therefore z is equal to minus 1. Okay, so the answer is 1 minus 1 minus 1. Now given, next question, given force is equal to alpha by density plus beta cube. What is the dimension of alpha and beta? This is the question. Force is equal to ml T raised to minus 2 is equal to alpha by density ml raised to minus 3 plus beta cube. Therefore, ml raised to minus 3 is equal to beta cube, which implies beta is equal to m raised to 1 by 3 L raised to minus 1. Okay. Then again we can write ml T raised to minus 2 alpha by ml raised to minus 3. Therefore alpha is equal to m square L raised to minus 2, T raised to minus 2. So these are the alpha, beta of C. The answer is C. Next one. If epsilon 0 permittivity of vacuum, M is mass, L is length, T is time, A is electric current, then what is the dimension of epsilon 0? That is the question. So epsilon 0, here that is actually 1 by 4 pi epsilon 0 r square into Q1 Q2 is equal to F. So which implies epsilon 0 is equal to Q1 Q2 by Q1 Q2 by F r square. Okay, is equal to A square T square by ML T raised to minus 2 into L square is equal to M raised to minus 1, L raised to minus 3, T raised to 4 A square. Minus 1, L raised to minus 3 A square. The answer is B. Okay. Next. If force, velocity, time are taken as fundamental units. Force, velocity, time are taken as fundamental units, then the dimensions of mass. So we know that F is equal to M into A is equal to M into velocity by time. Okay. Force, velocity, and time. Okay. So M is equal to F into T. By B. So it will be F P raised to minus 1 T. F P raised to minus 1 T. D is the answer. Next. A quantity is given by x is equal to epsilon 0 L V by T, where V is voltage, potential difference, L is length, T is time. So we have to find similar dimensions of x are same as that of the dimensions of x are same as that of, then we have to find the dimensions of x. It should be same of one of this. So first we will find out the dimensions of this. So V voltage is actually W by Q is equal to M L square T raised to minus 2 by Q. Q is a T. So M L square T raised to minus 3 A raised to minus 1. Okay, that is B. Dimensional B. Next one, epsilon 0 is equal to 1 by 4 pi F Q1 Q2. So A square T square by 1 by 4 pi F R square. Okay. So F is ML T raised to minus 2 into L square. So it is M raised to minus 1 L raised to minus 3 T raised to 4 A square. Okay. Now we have x is equal to epsilon 0 is M raised to minus 1 L raised to minus 3 T raised to 4 A square into L is the length, this means L. V is actually we have found out b actually m l square t raised to minus 3 at, okay, divided by t, okay, is equal to m raised to minus 1, m will get cancelled, l raised to minus 3 and l cube get cancelled, t raised to minus 3 and t raised to 4, t raised to 4, t raised to, when this t goes up, this raised to minus 4, so all this will get cancelled. So a this is actually, one second, there is one small mistake, t is not there, it's actually not t, a raised to minus 1. So a raised to minus 1 in this a raised to minus 1, this is actually a, the answer is actually current, okay, so it is equal to current, so it is d is the answer, its answer is d, a, all this will get cancelled and you will get a. Next question, tracking. Next question, taking electronic charges as E and permittivity at epsilon 0, use dimension analysis to determine the current expression for WP, angular frequency. Hence, n is the, here n is the number density of the fluid. Now, when we say angular frequency, okay, angular frequency WP is equal to, we know that t raised to minus 1, okay, dimensional WP, angular frequency is t raised to minus 1. Then number density is the number of photons per unit volume, okay, number density is the number of photons per volume, number density n is equal to number of electrons per volume. Now we have 4 options given. So permittivity epsilon 0, then here what is given for WP, we have to find an expression, so that the expression should give the result t raised to minus 1, because WP is t raised to minus 1. Therefore, both sides LHS and RHS should be same. So for t raised to minus 1, for getting, first let us find out what is epsilon 0. We know epsilon 0 is equal to 1 by 4 pi f r square into q1 q2. Okay, so s square t square at, q is 84, q1 q2 is equal to s square t square by f is ml t raised to minus 2 into l square. So what we will get, m raised to minus 1, l raised to minus 4, 3, t raised to 4, a square. This is epsilon 0. So now the expression we should get is at t raised to minus 1. For getting t raised to minus 1, we should get t in the denominator. Okay, that means actually here t denominator means actually the epsilon 0 should be in the denominator. Sorry. Then in epsilon 0 there is an a square. Therefore, this a square should get cancelled. For that, in the numerator, we should have some a square. That you will get from e square. Okay, e square is charge only, charge square. So there will be a square t square. So both will get cancelled. So let us try c first. Okay, what is c? C is actually square root of n e square by m epsilon 0. So so that n is equal to number density is equal to n by l cube is equal to l raised to minus 3. Then square root of n square by m epsilon 0 is equal to n is actually l raised to minus 3. Okay, e square a square t square divided by m epsilon 0 is equal to m raised to minus 1 l cube t raised to 4 a square l raised to minus, okay, l raised to minus 3 the whole of half is equal to l cube will get cancelled, m and m raised to minus will get cancelled, s square also will get cancelled. So we will get t square square root of half, we will get t raised to minus 2, we will get t raised to minus 1. So the answer is C. Next one. The voltage of a bulb. Voltage of the bulb rises 220 volt. 100 watts drops by 2.5% of its rated value, and the percentage of the rated value by which the power would decrease is, we have to find out. We know that power is equal to d square by r. Okay, therefore delta P by P is equal to 2 into delta V by V plus delta R by R. So here what happens? What is given? The voltage of the bulb is 220. P is equal to 220 volt. Okay, voltage drops by 2.5%. So voltage drops by 2.5%. That means actually 2 into delta V by V. Delta V by V in 100% into 100. Okay, 100% into 100%. So delta V by V is equal to 2.5 plus delta R by R is actually 0, since it's a constant. R is a constant. R is not changing here. Only voltage is changing. This is 0. So delta P by P is equal to 2 into 2.5 is 5%. Delta P into P in 100% is equal to delta 2 in delta B by V in 100 and delta R by R in 100. So delta P by P in 100 is equal to 2 into 2.5 is equal to 5%. Next one. What is the value of 5 into 10 raised to minus 6 into 5 into 10 raised to minus 8 with the due regards to significant figures? Now here the significant figure is 2. Therefore, when it is multiplied 5 into 5, it's 25. 25 having two significant figures. Therefore, 25 will be the answer into 10 raised to minus 14. So it is 25 10 raised to minus 14 will be the answer. So B is the answer. In an experiment, the percentage error occurred in the measurement of physical quantities A, B, C, D are 1%, 2%, 3%, 4% respectively. Then the maximum percentage error in A square B raised to half in divided by C raised to 1 by 3 into D cube. So this is what we wanted to find out. Actually, x is equal to given x is equal to A square B raised to half divided by C raised to 1 by 3 then D cube. So we know that here actually given A is equal to 1%, percentage error in A is 1%, B is 2%, C is 3%, and D is 4%. So delta x by x into 100 is equal to 2 into delta A by A into 100 plus 1 by 2 into delta B by B into 100 plus 1 by 3 into delta C by C into 100 plus 3 into delta D by T into 100. Okay, now it will give 2 into delta A by A into 100 is 1% plus half into 2%, B 4 plus 1 by 3 into 3% plus 3 into 4%. So it is 2 plus 1 plus 1 plus 12. So 12 plus 1, 13 plus 14 plus 2, it will be 16%. Check. Yeah, it is 16%. 16%. Okay, that is the answer. Next one. The distance traveled by a body, the nth second is given by Sn. Sn is equal to u plus a by 2 into 2n minus 1, where u is equal to initial velocity and a is equal to acceleration. Okay, then dimensions of Sn. So given u is equal to velocity, therefore Lt raised to minus 1. So because of that, Sn should have the same dimension. It should also have Lt raised to minus 1. So you should have the dimensions of velocity. Now, yeah, here actually the answer is B. But one thing we wanted to see that actually, see, u will have the same dimension as a by 2 into 2 a by 2 into 2n minus 1. That is Lt raised to minus 1. Lt raised to minus 1. So here, to get actually Lt raised to minus 1, for that actually a it is given actually as acceleration. Therefore, when we write the dimensions, Lt raised to minus 1 into 2n minus 1 is equal to Lt raised to minus 1, which implies (2n minus 1 is equal to Lt raised to minus 1 by Lt raised to minus 2. So it will be 1 by t raised to minus 1 is equal to t. Is equal to t. That means n is having the dimensions of t. This is not asked actually, but I am just giving what is the dimension of n. In case it is asked, you can find the dimension of n like this. Next question. Power P is related to distance x and time p and time t as p is equal to b minus s square by at. Dimensional formula of b. We have to find the dimensional formula of b. We have to find out b. Okay. Given power is equal to b minus s square by at. So power, we know power is actually work by time. That is work by time. That is m L square t raised to minus 2 by t. That is m L raised ml square t raised to minus 3. Okay, power. So here p is equal to b minus x square by at, which implies b is equal to x square. That is x is ultimately given distance, that means L square. So the dimensions of b is equal to L square. Next question. The area enclosed by a circle of diameter 1.06 meter with the correct number of significant figures is. So area diameter is given 1.06 meter. So area is equal to pi d square by 4. Since diameter is given is pi d square by 4. If it were a radius, it was pi r square by 2. Okay. It is pi r square if it is diameter given, but since diameter given, it is pi d square by 4. So pi into d square is 1.06 square by 4. So the area we are getting pi is actually 22 by 7. Okay, we will get 0.882828. But actually here significant figure is 3. Significant figure is 3. Therefore, we have to round it off to 3 figures. That's equal to 0.883. Since it is 8, this 2 will become 3. Now subtract. Next question, subtract 2.6 into 10 raised to 4. 2.6 into 10 raised to 4 from, okay, from 3.9 into 10 raised to 5. So first we have to make the power same. For instead of 3.9, we will write 39, okay, minus 2.6. So we will get 36.4 into 10 raised to 4 or 3.64 into 10 raised to 5. Okay. So since there is only 2 significant figures, we round it off to 2 figures. That will be 3.6 into 10 raised to 5. That will be the answer. System of units is a complete set of base unit, derived units, both A and B. It's a complete system of base units and derived units. Next, and in international system of units, there are 7 base quantities whose units are defined. Which physical quantity has prefix with the unit? Only one physical unit is having prefix, that is kilogram. Kilo is the prefix used. All others are not having any prefixes. Okay, whether it is mass, whether it's mass is meter, then it's kilogram, then we have say this candela, okay, and Kelvin. Whichever one you take actually, and mole, whichever one you take, it will not have any prefix. Only kilogram is having the prefix. Physical quantity, a physical quantity used and result is expressed in NU. Okay, any physical quantity can be expressed actually N into U. N is the magnitude and U is the unit. Okay, now when a unit changes, okay, when actually it is N and U are inversely proportional, we know. Okay, when N increases, unit decreases. So what relation? It will be hyperbola. Okay, it will be hyperbola. The relation is hyperbola. Hyperbolic relations. It will be rectangular hyperbola to be fair. The dimensionless quantity never has a unit. If something is not having any dimension, it may have a unit or may not have a unit. Okay, it may have a unit. Why? Because for example, we can tell actually angle. Angle is radian. It has a unit. Radian. Steradian has a unit, but it has no dimensions. Okay, because the ratio of 2 lengths. Plane angle and solid angle have both units and dimensions. Units but no dimension. It is plane angle is radian and solid angle is steradian. It has units but it has no dimensions. So which of the following physical quantities have the same unit in all the 3 systems unit? Mass, length, time. None of this. Time. Whether CGS or whether it is actually FPS or whether MKS or SI, it is the same. Okay, for seconds it is second only. For time it is seconds. PQR are physical quantities having different dimensions, which of the following combinations can never be a meaningful quantity? Here, first one given is P minus Q by R. When the dimension is, because P minus Q by R means P is equal to Q. But since P and Q are having different dimensions, this cannot be correct. So it is not possible. Since it is already given P and Q are having different dimensions. Therefore, P cannot be equal to Q. Therefore, the first one is, first combination is not meaningful. Next question. If x is equal to at plus bt square, x is the distance traveled by the body in kilometers, t is the time in seconds, then unit of t. So x is equal to, x is given natural distance. So dimension of x is equal to L. Okay. Now at is equal to bt square. Okay. So again, we have to find the dimension of b. So dimension of x is equal to dimension of bt square. Okay. So L is equal to bt square. So b is equal to L by t square is equal to L t raised to minus 2. So LT is minus actually meter second raised to minus 2. It's not meter, it's kilometer. Okay, given kilometer. Kilometer is second raised to minus 2. Kilometer per second square. So 3 is the answer. Next one. An equation given p plus a by b square is equal to b into theta by b, where p is equal to pressure, okay, that is F by A is equal to m L raised to minus 1 T raised to minus 2. Then b is volume, b is equal to L cube, theta is equal to K, absolute temperature. Then we have to find the dimensions of A. So P is equal to A by B square. Okay. P is equal to A by B square. So B is volume, that is A by L raised to 6 is equal to ml raised to T raised to minus 2. So A is equal to m raised to minus 1 m L raised to minus 1 T raised to minus 2 into L raised to 6. So what will get? M L raised to 5 T raised to minus 2. That is the answer. Next question. The equation of the state of gas is given as universal. Okay, if the equation of the state of gas is given by P plus A by B cube into V minus P square is equal to Ct, where P, V and T are pressure, okay, volume and temperature. So A, B, C are constant. Dimensions of A and B to be found. So we know that P is equal to A by B cube. Given. So it's equal to M L raised to minus 1 T raised to minus 2. So A is equal to M L raised to minus 1 T raised to minus 2 into B cube is L raised to 9. L cube, the whole cube. It's equal to M L raised to 8 T raised to minus 2. So A is equal to M L raised to 8 T raised to minus 2. So the answer we can say is first one is even though let us see what is the value of B also. So again, we know B is equal to B square. Okay. So L cube is equal to B square. So B is equal to square root of L cube is equal to L raised to 3 by 2. So B also we found out. So the answer is B is equal to L raised to 3 by 2. A is equal to M L raised to 8 T raised to minus 2. Next one. The velocity v of a particle time t is given by velocity is equal to at plus v into t by b divided by t plus c. A, B, C are constants. Dimensions of A, B, C are to be found out. So velocity v. So velocity v means Lt raised to minus 1 is equal to at. Okay, which means A is equal to Lt raised to minus 1 by t is equal to Lt raised to minus 2. Okay, so A is equal to Lt raised to minus 2. Now t is equal to c, which means dimension of c is equal to t. Again, b by t plus c is equal to b dimensions. So b divided by t is equal to Lt raised to minus 1, which implies b is equal to Lt raised to minus 1 into t is equal to L. So dimension of b will be L. So A is Lt raised to minus 2, B is L, and C is equal to t. First one is the answer. Next question. The time dependence of physical quantity P is given by P is equal to P0 exponential of minus alpha t square. Minus alpha t square. Alpha is the constant and t is the time. The constant alpha. So since e raised to minus alpha t square is dimensionless, alpha shall be t raised to minus 2. Then only t raised to minus 2 and t raised to 2 we will get actually dimensionless quantity. Should t raised to minus 2. So it is dimension t raised to minus 2. Okay. Next one. Which of the following relations for the displacement of a particle undergo simple harmonic motion is not dimensionally correct? A is in meters, T and T are T and T, and seconds and omega is in second raised to minus 1. We know that first one y is equal to A sine 2 pi t by t. Okay, because the sign of x or whatever expression we are getting inside the sign, that will be dimensionless. So together the sign function shall be dimensionless. So here actually 2 pi t by t, so that when you take the dimensions t and t will get cancelled. Actually 2 pi t by t cancelled, it will become dimensionless. Second case, cos omega t. Cos omega t, omega is equal to, you know, that t raised to minus 1. So it will also, since omega is t raised to minus 1, omega t raised to minus 1 into t, it will become dimensionless. Okay, cos omega t is equal to t raised cos of t raised to minus 1 into t. So it is dimensionless. Next one is actually a by t, okay, into sine t by a is equal to y. Okay, so y, we know it is length, so it is going to be L. So we have to get, ultimately we have to get to L. So a by t means okay, sine t by a. Sine t by a to make it dimensionless, a shall be t. Here what happened if a is equal to t, because to get the term inside the sign dimensionless, we have to make a is equal to t. Okay, so then only you will get dimensionless. If a is equal to t, the problem here is actually next is a by t. Actually, that the expression given is a by t sine a by t. So sine t by a. So if a is equal to t, this will become dimensionless. Then a by t should be equal to L. For getting a by t is equal to L, if a is also t, then you will not get actually L raised to 1. So that means actually it is dimensionally wrong. The left hand side is not equal to the right hand side. So that expression is not correct. So the expression 3 is not correct actually. Not dimensionally correct. Okay. Next one. The displacement of a progressive wave is represented by y is equal to sine omega t minus kx, where x is distance and t is time. The dimensions of w by k are same as that. Since actually sine, since actually that sine wt minus kx, okay, it is dimensionless, we can write wt is equal to kx, which implies w by k is equal to w by k is equal to x by t is equal to L t raised to minus 1. So it is velocity. X by k is velocity. Okay, next one. Find the dimensions of intensity of power. Intensity, then power, then gravitational constant, then eta, coefficient of viscosity, Planck's constant, etc. Let's first find out intensity. Okay, intensity. What is intensity? Is power per area, unit area. Okay, so power, we know what is power. Power is actually force by area is equal to force by area. Sorry, not force by area, work by time. Okay, power. Work is actually m L square t raised to minus 2, okay, by time t by t area divided by area for intensity per meter. So this is actually L square. This L square and this L square will get cancelled. Therefore m t raised to minus 3. Next one, power already we found here work by time. Okay, so it is actually power is equal to m L square t raised to minus 2 by time is equal to m L square t raised to minus 3. Next one is G, universal gas mean our gravitational constant. G is equal to F R squared by M1 M2 is equal to ML t raised to minus 2 into L squared by M squared is equal to M raised to minus 1 L cube t raised to minus 2. Okay. Next, viscosity. Viscosity eta is equal to viscosity eta is equal to F by A into velocity dV by dx, velocity gradient. A is area, F is force. So F is actually m L t raised to minus 2 by L square into dV by dx is actually L t raised to minus 1 by L. It cancels. Okay, so what we get is actually m L will get to m L raised to minus 1 then t raised to minus 1. Next is Planck's constant, H. Planck's constant, H is equal to E by F. So m L square t raised to minus 2 by t raised to minus 1 is equal to m L square t raised to minus 1. Okay. Now wavelength lambda. Wavelength lambda is nothing but distance L. We know that. Wave number is 1 by lambda. Is L raised to minus 1. Okay. Next one. Angular displacement. Angular displacement I is equal to angular displacement. Angular displacement is equal to displacement by radius is equal to L by L is equal to dimensionless. Okay. Now angular velocity. Angular velocity is equal to linear velocity by radius is equal to L t raised to minus 1 by L is equal to t raised to minus 1. Next one, angular acceleration. Angular acceleration is linear acceleration by radius L t raised to minus 2 by L is equal to t raised to minus 2. Angular momentum is equal to mvr or I omega is equal to m L square t raised to minus 1. Moment of inertia. Moment of inertia I is equal to mr square is equal to ml square. Next one is Planck's constant. Now we should know the Planck's constant H is equal to, we have found out ml square t raised to minus 1, same as angular momentum. This also we are getting same. So Planck's constant and angular momentum are having the same dimensions. Angular momentum. Okay, both are having same dimensions. Then pressure, we know pressure is actually pressure is equal to force by area is m L raised to minus 1 t raised to minus 2. Same as stress. Okay, stress is equal to same as modulus. It can be bulk modulus, bulk, young, shear. Which will be the modulus, all have the same dimensions. Also energy density, energy is equal to energy density, all having same energy density. Is equal to epsilon E square is equal to B square by epsilon square. All are having the same dimensions. Now energy, you know, energy is equal to work is equal to torque, all having ml square T raised to minus 2. Now coefficient of viscosity eta is equal to ml raised to 1 T raised to minus 1. Already we have calculated that. The ratio of dimensions of Planck constant, and that of moment of inertia. Okay, so ratio of dimensions of Planck constant. Planck constant, we know that E by frequency. So m L square T raised to minus 2 by T raised to minus 1 is equal to m L square T raised to minus 1. Now moment of inertia I is equal to mr square m L square. Okay, so the ratio will be m L square T raised to minus 1 by m L square. So will be T raised to minus 1. So 1 by F is equal to frequency. Okay, the answer is 2. Now formula of torque. Torque, we know formula of torque and the same dimension of the work done. Formula of angular momentum is equal to I omega or MBR is equal to ml square T raised to minus 1. Charge, we know AT. Epsilon also we have already found out. Q1 Q2 by 4 pi FR square. You will give m raised to minus 1, L raised to minus 3, G raised to 4 A square. Velocity of light C is equal to nothing but the velocity of light is well T raised to minus 1 it should be. So there is a formula C is equal to 1 by square root of epsilon 0 mu 0. Okay, which implies C square is equal to 1 by epsilon 0 mu 0. Okay, from that you can find out C, you know, if you know epsilon 0 you can find mu 0, if you know mu 0 you can find out epsilon. And we know epsilon 0 just now we found out mu 0 from this actually mu 0 is equal to 1 by C square epsilon 0. Now 1 by epsilon 0 is equal to K is equal to Coulomb's constant. Coulomb's constant. Okay. Now resistance R is equal to V by I. Resistance is equal to W Q by I. V is equal to W by Q. So I is equal to W by Q I. Okay. So we can find out m L square T raised to minus 2 by AT into A. So it is m L square T raised to minus 3 A raised to minus 2. Again we know that time T is equal to RC is equal to L by R is equal to root of LC. So the dimensions we are taking R into C. Okay, you will get resistance and capacitance. Product of resistance and capacitance will give time. Then ratio of inductance to resistance also will give time. Then square root of LC also will give time. So since T is equal to L by R, which implies L is equal to R into T. So R we found out ml square T raised to minus 3 A raised to minus 2 into T. So M is raised to minus 2 A raised to minus 2. Now E is electric field. E is equal to electric field F by Q is equal to ml T raised to minus 2 by AT. Will give ml T raised to minus 3 A raised to minus. Okay. Next one is magnetic field density B is equal to F by QB is equal to ml T raised to minus 2 divided by AT into LT raised to minus 1. Okay, V is LT raised to minus velocity. Okay, so you will get M T raised to minus 2 A raised to minus 1. Next is now you will get actually B divided by E, you will get square root of epsilon 0 mu 0. Okay, so which implies B square is equal to B square is equal to E square into epsilon 0 mu 0. Energy density is equal to energy by volume is equal to m L square T raised to minus 2 by L cube is equal to m L raised to minus 1 T raised to minus 2. Okay. This will be same as B square by mu 0 is equal to epsilon 0 B square is equal to m L raised to T raised to minus 2. Now flux, electric flux is equal to electric field into area. When we say flux, we will be multiplying the P area. Okay, so electric field, we know F by Q is equal to ml T raised to minus 3 A raised to minus 1 into area is L square. Okay, so but we will get ml T raised to minus 1 A raised to minus 1. Similarly, magnetic flux is equal to magnetic field into area is equal to magnetic field. What is magnetic field B? So it will be mt raised to minus 2 A raised to minus 1 into L square is equal to m L square T raised to minus 2 A raised to minus 1. Minus 2 raised to minus 2 A raised to minus 1. Okay. Next one. Dimensions of resistance we already seen. Dimensions of magnetic flux also we have already seen here. Okay. Now stress is nothing but pressure is equal to force by area ml raised to T raised to minus 2. Which of the following 5 physical parameters are the same dimensions? Okay. Which 2 of the following 5? In this actually which are having the same dimensions. Here actually refractive index there is no dimension, dielectric constant there is no dimension. So you can say these two. Then energy density, we know that actually energy density is energy by volume. It is ml raised to minus 1 T raised to minus 2. Okay. So Young's modulus. Okay. This is stress by strain. It is nothing but pressure. Strain has no units. So pressure is by A ml raised to 1 T raised to minus 2. So energy density and Young's modulus or pressure have the same dimensions. Okay. Also, dielectric constant and refractive index are dimensionless also. You can also say these are having same dimensions also, you can say. Dimensions of Planck's constants equal to. So E is equal to h nu, E by nu or F. Nu is nothing but F. So it is ml square t raised to minus 1. Okay. The angular momentum, you know, omega ml square t raised to minus 1. So Planck's constant and angular momentum having the same dimensions. Which pair do not have equal dimensions? Energy and torque have the same dimensions. Angular momentum and Planck's constant just now we found out is the same dimension. Elastic modulus and pressure, okay, have the same modulus. Just now, in the previous question we found it is the same dimensions. Impulse is equal to force into time. Okay, impulse is equal to force into time. Sorry, not impulse. Impulse is equal to force in time, and momentum is equal to mv. Momentum is equal to m mass into. So impulse is equal to force into time. ml to minus 2. Force into time is actually ml to minus 2. Then momentum is equal to mass into L t raised to minus 1. Mass into velocity. So here force and impulse are given. So force and impulse having the force, but impulse is having the same dimensions of momentum, not force. This is actually momentum. These are same, but it is not. Impulse is equal to force into time. Therefore, force is having dimension m L t raised to minus 2. So force and impulse are having different dimensions. It's not the same. Dimensions of RC. Just now we have seen that RC is equal to dimensions of time. Okay, same dimension of time. Which of the following pairs of physical quantity does not have the same dimension? Work and torque have the same dimension. Angular momentum, Planck constant have the same dimension. Impulse and linear momentum is having the impulse and linear momentum having the same dimensions. Then surface tension is force field like this, ml t raised to minus 2 m t raised to minus 2. Tension is nothing but force. It is m L t raised to minus 2. So surface tension and tension are having different dimensions. Now, find the dimension of thermal conductivity. Find the dimension of thermal conductivity. Coefficient of thermal conductivity of a solid material is the rate of flow of heat per unit area. Rate of flow of heat per unit area per unit temperature gradient across the solid. So the formula for the coefficient of thermal conductivity include quantities like heat, length, area, temperature, and time. So we know that the formula of the coefficient of thermal conductivity is follows. Actually, it is K thermal is equal to Q into dx by dt or delta x by delta t. Q into delta x by delta t. So divided by A and T. So area and time. Okay. It is the dx by dt is the temperature gradient. So temperature is time. The dimensions quantities for heat is nothing but the energy. It is ml square t raised to minus 2. For area, A is equal to L square. Then K thermal is equal to Q into delta x and delta t. Q for delta x we can write L. Okay. Now the formula is Q delta x by delta t into A t. Okay, divided by A t. So Q we know ml square t raised to minus 2. Delta is nothing but L. Okay, and delta t is K. then A into T. Okay, so it will be A means L square. A is L square, okay? T. L square into T. So L square and L square will get cancelled. Then it is M L T raised to minus 3, T raised to minus 1. Okay. Scale to K thermal. So the dimension of the coefficient of thermal conductivity is ML T raised to minus 3, T raised to minus 1. Now we have to find the dimensions of thermal resistance. Thermal resistance. Remember that thermal resistance R is equal to delta T by Q, where Q is equal to the rate of heat flow. Rate of heat flow. Heat flow is nothing but energy. Therefore, it is M L square T raised to minus 2 divided by time. So, M L square T raised to minus 3. So, R is equal to delta T. Delta T is K, Kelvin, divided by M L square T raised to minus 3 is equal to M raised to minus 1, L raised to minus 3 to T cube K. This is the answer. If momentum P, area A, and time T are taken as the fundamental quantities, then energy has the dimensional formula. So we know that energy is equal to ml square T raised to minus 2. Okay. Same way is equal to force into distance. Force we know m into A into distance. That is m into v by t. Velocity by time is distance. Okay. Velocity divided by t is acceleration. So m into velocity by time into distance. Okay. Now m into v is nothing but momentum. Mass into velocity is momentum. Okay. So momentum divided by time into distance is square root of area. Okay. So what we are seeing is actually we have to make the we have to find the dimension with the base with the fundamental quantities momentum, area, and time. Now we have momentum, area, and time as we brought it here. Now if momentum is P, area is square root of area is A by 2. T is T raised to minus 1. So it is P raised to 1, A raised to half, T raised to minus 1. Okay. So P raised to 1, A raised to half, T raised to minus 1. Yeah. It's a small mistake here. It is P raised to 1. Okay. P raised to 1. Then A raised to half, L is to half, T is to minus. This is the answer for this. Okay, next one. If force is equal to F, acceleration A, time T are chosen as fundamental quantities. So it's like we're talking about force, acceleration, and time are chosen as the fundamental quantities. We know that. Find the dimension for energy. So energy, force into distance. Okay. So then distance then actually acceleration is equal to distance by time square, which implies distance is equal to acceleration into time square. So energy is equal to force into acceleration into time square. So fundamental units are, quantities are force, acceleration, and time. So is equal to force F, acceleration is A, time is T, FAT square. So FAT square, answer is first one, FAT square. Next one. A physical quantity of the dimensions of length that can be formed out of Cg and E square by 4 pi epsilon 0. C is the velocity of light, G is the universal constant of gravitation, and E is the charge. So a physical quantity of the dimensions of length that can be formed out of G, Cg, and E square 4 pi epsilon 0. So we know that. Let us find out our fundamental quantities are C, G, and E square 4 pi epsilon 0. So we know C is equal to, C is nothing but velocity, okay, of light. It is Lt raised to max. Okay. Now we know that F is equal to G m1 m2 by r square, which implies G is equal to Fr square by m1 m2 is equal to ml t raised to minus 2 into L square by m square, which is m raised to minus 1 L cube t raised to minus 2. So we got G, we got C. Okay. Now we have to find out epsilon 0. Now we know F is equal to 1 by 4 pi epsilon 0 Q1 Q2. Okay. Or Q1 Q2 or E square. So this is E, this is also charge. We can also write 1 by 4 pi epsilon 0 E square. So sorry, 4 pi epsilon 0 R square and E square. R square. So therefore E square by, if we can write E square by 4 pi epsilon 0 is equal to F R square is equal to ml t raised to minus 2 into L square, that is m L cube t raised to minus 2. Okay. Now let us check each case one by one. Case 1. That is C square into G into G square by 4 pi epsilon 0, the whole raised to half. So C square is equal to LT raised to minus 1 the whole square into, now G is m raised to minus 1 L cube t raised to minus 2, then E square by 4 pi epsilon 0 is m L cube t raised to minus 2. So we will get L square t raised to minus 2 L raised to 6 t raised to minus 4 the whole raised to half. So it is L square t raised to minus 2 L cube t raised to minus 2, which is L raised to 5 t raised to minus 4. Case 2. Case 2 is 1 by C square into E square by G into 4 pi epsilon 0 whole raised to half. So it's equal to 1 by C square is actually 1 by LT raised to minus 1 the whole square, okay, into m L cube t raised to minus 2 divided by m raised to minus 1 L cube t raised to minus 2 the whole raised to half. Is equal to m raised to minus 2 t square, okay, when it goes up it is L minus 2 into t square, then m raised to minus 2, okay, then L cube to these 2 cancels, m raised to minus 2 the whole raised to half. So what you will get? M raised to minus 1 L raised to minus 2 t square. Next one, case 3. Case 3 is one by c square g e square by 4 pi epsilon 0 is equal to 1 by c square is l raised to minus 2 t square into m raised to minus 1 l cube t raised to minus 2 into m l cube t raised to minus 2, okay, which will give l raised to minus 2 t square l raised to 6 t raised to minus 4. This l raised to 4 t raised to minus 2. Now case 4. Case 4 is 1 by c square g e square by 4 pi epsilon 0 the whole raised to half. It will give l raised to minus 2 t square into m raised to minus 1 l cube t raised to minus 2 ml cube t raised to minus 2 the whole raised to half is equal to l raised to minus 2 t square l cube t raised to minus 2 is l. These two will get cancelled, then you will get L. Okay. So the question was physical quantity of the dimensions of length. We have to find the dimensions of length. Dimensions of length we will give by the fourth equation. Okay. Fourth expression you will get L. Planck's constant h, speed of light in vacuum, and Newton's gravitational constant g are three fundamental constants. Which of the following combinations of these has the dimensions of length? Speed of light in vacuum is c. Okay, so we have three fundamental quantities. One is actually h, second is c, third is g. Okay, Planck's constant, speed of light in vacuum, and the gravitational constant. So we are supposed to find out which of the following combinations of these has the dimensions of length. So we say length is proportional to h raised to a, c raised to b, then g raised to c. Okay. So h we know E by frequency is equal to m l square t raised to minus, sorry, ml t raised to ml square t raised to minus 2 by t raised to minus 1. Frequency t raised to minus, that is m l square t raised to minus 3. Okay. H is m l square t raised to, sorry, not minus 3, minus 1. Minus 2 and minus 1. Minus 1. Okay. Now g we know fr square by m1 m2 which is equal to ml t raised to minus 2 into l square divided by m square, which will give m raised to minus 1 l cube t raised to minus 2. Okay, so we got g also, m raised to minus 1 l cube t raised to minus 2. C we know is nothing but velocity of light, so l t raised to minus 1. We are no doubt in that. So we have l raised to 1 proportional to h is m l square t raised to minus 1 the power raised to a. Then c is l t raised to minus 1 power raised to b. Then g we have m raised to minus 1 l cube t raised to minus 2 the whole raised to c. Thus, Thus, it is proportional to m raised to a minus c, a minus c, then l raised to 2a plus b plus 3c, then t raised to minus a minus b minus 2c. Okay, which implies a minus c is equal to 0, that is a is equal to c. Then 2a plus b plus 3c is equal to 1. So here, if we are substituting a is equal to c, we will get (2a plus b plus 3a is equal to 1, that is 5a plus b is equal to 1. Okay, this is the first equation. Again, what we got is actually minus a minus b minus 2c is equal to 0. Okay, if a is equal to b, then you are substituting for b. Minus 2a minus 2c is equal to 0, that is a plus c is equal to 0, which implies a is equal to c. Okay, we can a is equal to c. Okay, so we'll do another question. Minus instead of that a c we will substitute. So a is equal to b. So we will put actually so we have a is equal to c. So we put a here. So minus a minus b minus a minus b minus 2a is equal to 0. That is minus 3a minus b is equal to 0. That is 3a plus b is equal to 0. Now, we will keep it like this. This is question number 2. So, we will write it here. Minus 3a minus b is equal to 0. So, we are adding both. B will get cancelled. 2a is equal to 1, which implies a is equal to half. Since a is equal to c, then c is also half. Then substituting the value of a in equation 1, 5 into 1 by 2 plus b is equal to 1. So b is equal to 1 minus 5 by 2 is equal to 1 is 5 by 5. Okay, so it is, sorry, 1 is 2 by 2. So we will get minus 3 by 2. So b is minus 3 by 2. So what we received is a is equal to half, b is equal to minus 3 by 2, c is equal to half. Our equation is L is proportional to h raised to a, then c raised to b, g raised to c. That is h raised to half, c raised to minus 3 by 2, g raised to half. That is square root of hg by c raised to 3 by 2. Okay, so it is 3. Answer is 3. We got the equation here. Okay. Next one. Now energy G. Now next question. Energy E, velocity V, and time T are the fundamental quantities. Then we have to find out surface tension. Dimension for surface tension. Okay. Now what is surface tension? Surface tension is equal to force by length. So now force is equal to energy by distance, because energy is a force in distance, right? Distance. So energy by distance is velocity into time. So we have 3 fundamental quantities: energy, velocity, time. So we have to change it into energy, velocity, force, energy, velocity in time. But distance is equal to velocity in time. Okay. So we have E v raised to minus 1, t raised to minus 1. Now surface tension is, we take it here, force we got E v raised to minus 1, t raised to minus 1 divided by length. Length is actually Vt. So if you take it here, then surface tension is equal to E v raised to minus 2, t raised to minus 2. Okay, that is the result. We are getting 2. Okay. The dimension of critical velocity of liquid flowing through a tube is expressed as, we are given dimension of critical velocity is given as V0 is proportional to eta raised to x, rho raised to y, and r raised to z, where eta is equal to coefficient of viscosity of liquid, and rho is equal to density, then r is equal to radius of the tube, okay. Then we have to find x, y, and z, the dimensions of eta, rho, and z we have to find out. Sorry, not z, r we have to find out. Now let us see. Eta is equal to coefficient of viscosity. Viscosity is equal to F by A into dV by dx, velocity gradient. Okay. F we know, ml t raised to minus 2 divided by A is actually L square into dV by dx is equal to velocity gradient is Lt raised to minus 1 by t. Okay, Lt raised to minus 1 by t. Sorry, velocity divided by L will be dx. That is equal to L and L will get cancelled. So this L and 1L will cancel. Therefore, m L raised to minus 1. Then L raised to minus 1, then T raised to minus 1. Okay, this is actually coefficient of viscosity. Rho we know as mass by velocity, mass by volume, m L raised to minus 3. Okay, no problem. And radius is equal to nothing but L. So V0 is equal to critical velocity is equal to L T raised to minus 1 is equal to, or is proportional to eta, we know, m L raised to minus 1, t raised to minus 1, or raised to a, then rho is actually m L raised to minus 3, or raised to b. Now, okay, b or x we can give. Y, then radius is L. L raised to Z. Okay. Now it is proportional to M. We are taking actually M raised to X plus Y, then L raised to minus X minus 3Y. Now length plus Z. Okay. Then T raised to minus X minus 3Y. Okay. Minus 6 plus minus 3Y. So this is what we will get. Okay. So we will get equation x plus y is equal to 0. Then minus x minus 3y plus z is equal to L1 we will get. Then t raised to x minus 3 plus z is equal to 1. Then next equation is minus x minus 3 plus 1. Then yeah, here actually here 3 is not there, minus x. Okay, t raised to minus x only. Okay, minus x. Now what happens? Then minus x is equal to minus 1, which implies x is equal to 1. When x is equal to 1, then y is equal to minus 1. Okay, so y is equal to minus 1. Then when substituting both x is equal to 1, minus 1, then y is equal to minus 1 plus 3 plus z is equal to 1, which implies minus 3 plus 1, then implies 2 plus z is equal to 1, thus z is equal to minus 1. So x, y, z is equal to 1 minus 1 minus 1. This is the answer. Okay. Next question is, if force, velocity and time are taken as fundamental units, okay, F, V and T are taken fundamental units, then we have to find out dimensions of mass. Okay, so we know F is equal to M into A. So force is one thing, then now this we have to change, which implies M is equal to F by A. So force is already there. A is equal to velocity, V by acceleration is equal to V by T. Okay, so V by T means F T V raised to minus 1 should be F T V raised to minus 1. This is the definition. Okay, velocity by time is acceleration. The frequency of vibration F of a mass M suspended from a spring constant K is given by a relation F is equal to A M raised to X K raised to Y, where A is a dimensionless constant and value of X and Y we have to find out. Okay, now it is given frequency F is equal to A M raised to S K raised to Y, where A is dimensionless, is given less constant. Okay, now M is the mass, K is spring constant. We will find out X and Y. This is the question. So what is the spring constant? First let us see what is spring constant. Spring constant is a measure of a spring stiffness. By this we can find out how much force is required to stretch or compress a spring. The higher spring constant indicate that the stiff spring. Okay, means you need more force to compress or stretch it. So, for understanding the behavior of a spring and other elastic material, this spring constant is used. The spring constant is defined by Hooke's law, okay, which states that force F required to compress or extend the spring is proportional to the distance. The force F required to compress or extend, stretch a spring is proportional to distance S. Okay, distance S, and is displaced from the equilibrium position. So F is proportional to the distance. So F is equal to Kx. But here the thing is that this is given a minus sign. F is equal to minus K. Why the minus sign is given? The negative sign indicates that the restoring force acts opposite direction to displacement. Because if the spring is there, okay, so if you are giving a force in that direction, okay, so it's the restoring force. Restoring force acts in opposite because you have stretched the spring. Restoring force acts in the opposite direction. Okay, X, you have stretched that because it was X, then you stretch to delta X. Okay, but the restoring, but in that for that you have applied a force this direction. But the restoring force will act in the opposite direction because you stretched here, but it is trying to go back to the original condition. So the restoring force is in the opposite direction of the movement. Therefore, is given a minus sign. So F is equal to minus Kx. Now the unit of F is Newton per meter. Okay, spring constant K. So unit of spring constant K is Newton per meter. Why? Because F is equal to Kx, right? So K is equal to F by X. F is in Newton, then X is the displacement in meter. So this is 2 Newton per meter, right? To like that. So let us show this pictorially. So you can see here the spring F is there, okay, and is moved with distance X, okay. Then F is equal to minus Kx. So here we know that here the expression what is given is frequency is equal to A m raised to X K raised to Y. We have to find out Y and K. So X. So we know that K is equal to F by X. So F is equal to ml T raised to minus 2 divided by L. Okay. So what you will get? You will get ml T raised L will get cancelled. So you will get m T raised to minus 2. M T raised to minus 2. This is actually okay. Okay. So then F is equal to T raised to minus 1. It's the frequency, nothing but frequency. So we can write T raised to minus 1 is equal to A is the dimensionless constant. Okay. So we don't have to consider this. Okay. Now m raised to X. K we know m T raised to minus 2 raised to Y. Then which is equal to m raised to X plus Y T raised to minus 2Y. So from this we will know X plus Y is 0 because here it is m raised to 0, L raised to 0. So X plus Y is equal to 0. Then next expression what we are getting is actually minus 2Y is equal to minus 1, which implies Y is equal to 1 by 2. Okay. So if Y is equal to 1 by 2, if you put it here, you will get x is equal to minus 1 by 2. So you got the values x is equal to 1 by 2 and y is equal to, sorry, x is equal to minus 1 by 2 and y is equal to 1 by 2. That is the answer. Let us see whether that answer is here or not. Yes, x is equal to minus 1 by 2 and y is equal to 1 by 2. The fourth one is the answer. Okay. Next question. Which of the following system of units is not based on the unit of mass length and time error? So M, L, and T. So FPS, it is actually mass, length, and okay. F is foot and P is pound and S for second. So this is based on mass, length, and time. Then CG system, it is the same. CG is also centimeter, gram, seconds. MG is also meter, kilogram, seconds. So the SI unit is not based on these 3 units only. It does 7 fundamental units. So the answer is, which of the systems is not based on the unit of mass, length, and time alone? So it is actually SI. The answer is given wrong here. It is 2. Answer is 2. Okay, SI system. SI system, there are 7 fundamental units. The dimensions of magnetic moment. So what is magnetic moment? Magnetic moment is I into A. Magnetic moment. Magnetic moment is equal to current into area. I into A. So it is actually A L square. Okay. So the answer is A L square. That is answer 2. L square A. Okay. So answer is given here. Answer is 2. Okay. No, sorry, not here. A L square can be here. 2. The dimensions of reluctance. We are going to find out the dimensions of reluctance. So reluctance is similar to electrical resistance in the electrical circuit. Okay. So a magnetic material's reluctance varies with flux density. So reluctance in a magnetic field, magnetic material is S is equal to mmf by flux. mmf is actually magnetomotive force. Magnetomotive force. And phi is magnetic flux. Magnetic flux. mmf is number of turns into current. Okay, current. So dimensions of mmf will be A. Then flux, we know that actually F is equal to B into QB. So B is equal to magnetic field B is equal to F by QB. So F is equal to MLT raised to minus 2. Q is equal to AI. So AT, sorry. V is equal to velocity LT raised to minus 1. Okay, minus 1. So this will get cancelled. T raised to minus 1 and T will get cancelled. So what we will get, M and L and L also will get cancelled. So what we will get, M T raised to minus 2, A raised to minus 1. Okay. So B is M T raised to minus 2, A raised to minus 1. So flux is equal, the dimensions of flux is equal to magnetic field into area. That is M t raised to minus 2 a raised to minus 1 into L square. Okay, we will get m L square t raised to minus 2 a raised to minus 1. So hence reluctance S is equal to mmf by phi is equal to a divided by m L square t raised to minus 2 a raised to minus 1. So you will get m raised to minus 1 L raised to minus 2 t square a square. Okay, this is the dimensions of reluctance. The velocity v of a particle is given by, so velocity v is given by at plus b by t plus c, where t is equal to time, then b, okay, it's already told it is velocity, then we have to find out the dimensions of a, b and c. Okay, so velocity b is lt raised to minus 1. Okay, is equal to a t plus b by t plus c. Okay, now we know since actually that t plus c is given in the denominator of b, we can say c is equal to t. So the dimension of c is equal to t. So again lt raised to minus 1 is equal to at, which implies a is equal to lt raised to minus 1 by t is lt raised to minus 2. Okay, now again lt raised to minus 1 is equal to b by t. Okay, so b is equal to lt raised to minus 1 into t is equal to l, b is equal to l. So it is lt raised a, b, c are given as lt raised to minus 1, l and t. So lt raised to minus 2, l and t. The answer is 3. In a particular system, the unit of length, mass and time are chosen to be 10 centimeter, 10 gram and 0.1 second respectively. The unit of force in the system will be, so we know that force is equal to mass into acceleration. So in the system, mass is in 10 gram. So 10 gram into acceleration is distance by time square. Okay, so distance is given, length is given in centimeter, so 10 centimeter, by time is given in seconds, so 0.1 seconds square, no, distance is meter per second square. So instead of meter it is 10 centimeter, second square 0 into 0.1 second square. Okay, so this is equal to, what is the unit here? So gram centimeter second raised to minus 2. Okay, so you will get 100 divided by 0.1 is 10 raised to minus 1, so 10 raised to minus 2. Okay, 10 raised to minus 2 gram centimeter second raised to minus 2. That is 10 raised to minus 2 when goes up, it is 10 raised to 4 gram centimeter second raised to minus 2. So when you want to convert it into Newton, Newton is 1 Newton is kilogram meter second raised to minus 2. So we have to convert this gram, we have to convert this gram centimeter per second square into kilogram meter second square. Okay, so 10 raised to 4 into gram when convert to kilometer, you multiply by 10 raised to minus 3. Centimeter, you multiply 10 raised to minus 2. Mean divided by 1000 is multiplied by 10 raised to minus 3. Okay. And second raised to minus 2. So that will be 10 raised to 4 into 10 raised to minus 5. Okay. Kilogram meter second raised to minus 2. Okay. This is actually kilogram meter. So that is 1 by 10 Newton. It's 0.1 Newton. The answer is 0.1 Newton. Okay, your answer is 1. Next one. The time difference of a physical quantity P is given by P is equal to P0 e raised to minus alpha t square, where alpha is the constant, t is time. Now we know e raised to minus alpha t square is dimensionless. Therefore, minus alpha t square should is equal to 1, which implies alpha should be t raised to minus 2. Okay, then only t raised to minus 2 into t square we will get 1. Okay, so the dimension of alpha is equal to t raised to minus 2 or 1 by t square. Okay, the answer is B. A unitless quantity never has dimension. So if there is no unit, there is no dimension. But if there is no dimension, there can be unit also. For example, angle. Okay, angle has no dimension, and solid angles also have no dimension. So the plane angle is having a dimension, and similarly for solid angle also we have stereo. Okay, and for the plane angle we have radians. Which of the following sets cannot enter into the list of cannot enter into the list of fundamental quantities in system units? So we know that actually time, length, time, velocity. So length and time, using length and time we can derive velocity. Therefore, this cannot be used because that fundamental quantity using fundamental quantity we cannot derive another fundamental quantity. Okay, therefore this is we cannot use time, length, and velocity as fundamental quantities. A dimensionless quantity may have a unit also. Okay, just like I told, the angle will have dimension of the radius, so it may have a unit also. This is actually that similar one. Just now we have done similar thing only. Okay, where v0 is the constant s greater than the position of x particle is given, the dimension of v0. Okay, here actually we had to find out the dimension of v0 and a, both we had to find out, unlike the earlier one. Okay, so here what is given is x is equal to v0 by a into 1 minus 0 raised to minus 8. Okay, where v0 is a constant and a is greater than 0. So what happens, just like we told earlier, 1 minus e raised to minus 8, actually that since this quantity 1 minus e minus 8, we can write like that, e raised to 8 is equal to 1. Okay, so therefore to getting this, actually a into t should be equal to 0. Then only we will get e raised to 0 is equal to 1. Okay, so we will get a into t is equal to 0. That means a is equal to t raised to minus 1. We will get an answer, a is equal to t raised to minus 1. Now yeah, here sorry, since e raised to 8t minus 8 is dimensionless, A t is equal to 1, sorry, whatever is wrong here. So A into t is equal to 1, that means A is equal to t raised to minus 1. Again, this quantity is dimensionless, okay, as we know. Here actually this 1 minus E is dimensionless. So X is actually, we know it is L. So V0 by A, we got actually t raised to minus 1. And this is dimensionless. So this we can, we don't have to take it. Now, we have to find out V0. Okay, what is V0 then? V0 is equal to L into t raised to minus 1. So it is L t raised to minus 1. Okay. So V0 is L t raised to minus 1. Then A is equal to t raised to minus 1. Okay, that's therefore the answer is 1. L t raised to minus 1 and t raised to minus 1. Now, the dimensions of intensity are, what is intensity? Intensity is equal to power divided by area. What is power? Energy by time by area. Energy is actually ml square t raised to minus 2 into, and time is t, area is L square. Okay, L square gets cancels, then we will get m t raised to minus 3. So it is m t raised to minus 3. Okay. Now the dimensions of RC, where R is resistance and C is capacitance, are same as that of time. We already learned this. Okay, we already told actually that RC is equal to T. So it is time. So we can do it in the long way also, but already I have given you this equation. RC is equal to T. So we can do it the other way also. We can find R, then we can find actually C, then we can do it also. C is Q by V. Then we can find out the dimension for that. Then you find R into C, multiply, you will get the same answer. Even if you do that, you will get the same answer. The dimension formula for magnetic flux. So magnetic flux, we know what is magnetic flux? Magnetic flux is equal to V into A cos theta. So cos theta is dimensionless. So V into A, and V, we know that actually F by QV into A. So F is equal to ml t raised to minus 2 by Q is equal to AT, V is equal to LT raised to minus 1 into area L square. Okay, this is actually area L square. So what will happen? T raised to minus 1 and T will get cancelled. Okay, this L and L will get cancelled. So what we will get? ml square T raised to minus 2 A raised to minus 1. So ml square T raised to minus 2 A raised to minus 1 is the answer. Okay, here we will see the answer here. Now the dimensions of resistance are the same as that of Planck's constant, charge. Okay, that of 4 combinations given. One is Planck, where H is Planck's constant, E is charge. So we have to find out which is having the same dimensions as resistance. So H, we know E by frequency, that is m L square T raised to minus 2 by T raised to minus 1 is equal to m L square T raised to minus 1. So H we can find out like this. Okay, now we know that E is equal to I squared RT. From this we can find out R is equal to E by I squared T is equal to m L square T raised to minus 2 divided by A square T is equal to M L square T raised to minus 3 A raised to minus 2. This will give resistance. So H by E square is equal to H, we have received M L square T raised to minus 1 by E square is A square T square. Okay. So M L square T raised to minus 3 A raised to minus 2. So we are getting same as resistance. H by E square is same as resistance. Okay. So that is the answer, H by E square. So it is, answer is 4. So how we arrived at H by E square? Okay, now some shortcuts we used here. Why we arrived actually mean H by E. We know that actually in see in resistance there is actually a term called A raised to minus 2. Okay, H there is no term as A no term of A. So for getting this A raised to minus 2, then the charge should come in the denominator. So charge is actually A unit we know. So that's how we have taken directly H by E square, because we know that E square is A square T square, and we will get A raised to minus 2 in the term in the numerator. Okay, but here actually if you check all the 4 answers, actually there is 2 things, H square E square, then H by E square. So we have taken H by E square first, but then H square if you are taking, you are getting something called something like actually M square. Okay, M square, and there is no term M square in the denominator, means for E. There is no term. But E anyway, E square we have to come in the denominator. But if you take H square also, you will get M square. So for resistance, there is no M square, there is only M raised to 1. So we cannot use actually H square in the numerator. That's why we have selected H by E square. Okay. Because actually when you see some some multiple choice questions, you have to eliminate it. You have to think actually which can be the answer. So there are ways, because that changes from question to question. So you have to think actually which can be the answer, so that you can save time. Okay, that is the idea. Next one, the pair having the same dimension is. So work and torque, you know the work and torque has the same dimensions anyway. Kinetic energy and velocity it is not. Okay, velocity is different, kinetic energy is energy, velocity is L to raised to minus 1, that cannot be the thing. Then work and torque only can be the answer. Okay, work and torque are same. Torque is nothing but actually force into distance. Okay, so if you take a couple, okay, you can give a force like this, distance is S, it is actually work only, force into distance. Okay, it's work only. M L cube T raised to minus 1, M L cube T raised to minus 1, A raised to minus 2 has the dimensions of. So let us see each dimensions. Rho is equal to resistivity Ra by L. Okay, so R actually we have found out in the last question. It is M L square T raised to minus 3 A raised to minus 2 divided by L is equal to M L T raised to minus 3 A raised to minus 2. Okay, so it is not matching. So conductivity is actually one-way rho. So that is also not matching. It is not one-way rho anyway. Then actually resistance already we found here. So it is not matching. This actually the answer is none of the above. None of the above is the answer. Next one. ml square t raised to minus 3 is the dimensions of. So m l square t raised to minus 3. Anyway, it does not work. Work is actually, we know ml square t raised to minus 2. Then power is actually work divided by time. So that is ml square t raised to minus 3. So it is actually power. This we know, this is actually power. ml square t raised to minus 3. Force we know it is ml t raised to minus 2. That is not correct. Momentum is mass into velocity is equal to m l t raised to minus 1. These are not matching. The only power is matching with this. Now, next one. If R and L represents the resistance and self-inductance. Okay, R is equal to resistance, L is equal to inductance. Then, which of the following is correct? We know XL is equal to inductive reactance, which is equal to resistance actually, is omega L. Omega we know is equal to 2 pi F into L. So, which implies F is equal to R by L. So frequency of F is equal to R by L, because actually the dimension we are taking. So the 2 pi is a constant, therefore we are ignoring it here. So frequency, the dimension of frequency should be equal to R by L. So the answer is 1, R by L. You can find it in the long way also. As shown here, actually you can find out the L, you can find out the R, you can take the ratio for each case, you can find out and check whether it is, but actually it is a multiple choice questions and all, you have to save time. So this kind of techniques you can use to find out the answer easily. Okay. So the dimensions of interatomic force constant, force constant. So what is interatomic force constant? Interatomic force constant is force per displacement. Okay. So force we know ml t raised to minus 2, displacement is L. So L and L get cancelled. So we get m t raised to minus 2. The answer is m t raised to minus 2. The dimensions of EMF in MKS. Strictly speaking, ampere is not a fundamental quantity in MKS, but actually since it is a precursor of SA, you can consider it as a ampere as a fundamental quantity. So actually it should be in SA unit only, ampere is given clearly as a fundamental unit, but in MKS also you can consider it as a fundamental unit since it is a precursor of SA. From MKS only this SA unit was formed ultimately. Okay, so let us consider like that only. So EMF, we know that actually voltage is equal to W by Q is equal to M L square T raised to minus 2 by AG. Okay, so it's equal to M L square T raised to minus 3 A raised to minus 1. So answer is 4. The physical quantities having same dimensions are torque and work. Torque and work is having the same dimensions and weight. Momentum and Planck's constant. Then stress and Young's modulus. Okay. So let us check one by one. Planck constant we know it is E by F, Planck's constant. H is equal to E by F is equal to M L square T raised to minus 2 in divided by T raised to minus 1 is equal to M L square T raised to minus 1. Then momentum is equal to mv is equal to ml T raised to minus 1, ml T raised to minus 1. So it is not same. Okay, momentum and Planck's constant are not same. Stress and Young's modulus or is the same dimension, they have the same dimension. Torque and work also have the same dimension. Speed. So we know that C is equal to 1 by square root of epsilon 0 mu 0. Okay. This is correct actually. This is correct. So this C is equal to speed of light. So it is 1 by epsilon 0 is 0. The dimensions are correct. Okay. Now again that stress and Young's modulus, but Young's modulus is actually Young's modulus is a stress-based strain. So strain has no dimensions, so it is equal to stress itself. Okay, stress by strain. Okay, strain has no dimension, so it is having the same dimension as stress. The dimensions of epsilon 0 is 0. Just now we have seen that actually C is equal to 1 by square root of epsilon 0 mu 0, which implies C square is equal to 1 by epsilon 0 mu 0. So epsilon 0 mu 0 is equal to 1 by C square is equal to 1 by LT raised to minus 1 the whole square is equal to 1 by L square T raised to minus 2 is equal to L raised to minus 2 T square. The answer is L raised to minus 2 T square. Dimensions of physical quantity X in the equation force X by square root of density is given by. Okay. Dimensions of physical quantity X. So we want to find out the dimensions of X. So the equation is given force is equal to X by square root of density. Square root of density. So we know that M LT raised to minus 2 is equal to X divided by density is actually mass per volume. So ml raised to minus 3 the whole raised to half. Okay. Therefore, X is equal to ml T raised to minus 2 into m raised to half L raised to minus 3 by 2. So it is m raised to 3 by 2 L raised to one minus 3 by 2. Okay, that is actually minus 1 by 2. Then T raised to minus 2. Okay. This is the dimensions. Next one. A quantity X is given by X is equal to epsilon 0 V by T. Okay. Here X is equal to epsilon 0 LV by T. We know epsilon is permittivity. Okay, permittivity. Then L is the length and T is time and V is voltage, potential difference. Okay, now we know that F is equal to 1 by 4 pi epsilon 0 r square Q1 Q2, which implies epsilon 0 is equal to 1 by 4 pi F r square Q1 Q2. Okay, so epsilon 0 is equal to 1 divided by 4 pi is a constant. So F is equal to ml T raised to minus 2 into L square into AT the whole square. This is equals to A square T square by m L cube t raised to minus 2 is equal to m raised to minus 1, m raised to minus 3, t raised to 4, s square is equal to epsilon 0. Okay. Now, voltage is equal to W by Q is equal to m L square t raised to minus 2 by AT. It will give m L square t raised to minus 3 a raised to minus 1. Okay. Now we will find out dimension of x, which is epsilon 0 L V by T. So epsilon 0 we have received m raised to minus 1, m raised to minus 3, t raised to 4 a square into L is length L into V. So space constraint is there, we'll write it here. M raised to minus 1, m raised to minus 3, t4 a square into L into V is m L square t raised to minus 3 a raised to minus 1 divided by T. Okay. So what will get? You will get m raised to minus 1, m will get cancelled. L raised to minus 3 into L square will get cancelled. See, this L cube and L raised to minus 3 will get cancelled. Then this T, then will get T cube, the T raised to minus 3 means T cube will get cancelled. Then we have got a square into a raised to minus 1, which is nothing but a into ampere. Okay, so it is current. It is current. Okay, not ampere, current. Okay, so we can say the dimension of x is equal to current. Okay. Given v is the speed, okay, v is equal to speed, then r is radius, then g is acceleration due to gravity. So the dimension you know L to raised to minus 2, speed is L to raised to minus 1, this is L. Okay. Now, which of the following dimensionless? So for getting dimensionless, we have dimensionless, what we will see. So speed is L to raised to minus 1. So g is L to raised to minus 2. So this square of this should be in denominator or numerator. Then only the t will get cancelled. This is t raised to minus 2. L square we will get to. Square means that v square means L square t raised to minus 2. So this 2 will get cancelled. Then one L is there, therefore this L shall come in the denominator, then it will be correct. Okay, so it can be v square by g into r. Correct. You will get like this. So the answer is v square by rg. First one is the answer, v square by rg. Okay. Then next one. The dimensions of electric potential is same as that of work. Electric field unit per unit charge, work per unit charge, force per unit charge. So we know that V is equal to W by Q. So it is actually work per unit charge. Work per charge is voltage. Okay. Work per charge is voltage. The answer is 3, work per unit charge. You can also find this by finding out the dimensions and all, then creating and all. But actually, as I told you before, since this is multiple choice questions and all, that is better to find some method to reduce the time. The dimension formula for latent heat. So we should see what is latent heat. Latent heat is energy per mass. Latent heat is the heat absorbed or released during phase change at constant temperature. So when ice change into water, water change into ice, something like that, because the phase change is there. Okay. So latent heat is the heat absorbed or released during phase change at constant temperature, has the same dimensions as energy per unit mass. So latent heat is equal to energy per mass. So it is m L square T raised to minus 2 by m. So you get L square T raised to minus 2. Okay, next question. V is equal to gamma P by rho square root of gamma P by rho, where V is equal to speed, then P is pressure, okay, rho is density, then what is the dimension of Y? What is dimension of gamma? So gamma, we have to find out the dimension of gamma. Okay, now V is equal to square root of gamma P by rho. Okay, then V square is equal to gamma P by rho, which implies gamma is equal to V square rho by P. So V is velocity or speed, Lt raised to minus 1 the whole square. Okay, then rho is equal to mass by volume ml raised to minus 3, okay, divided by P. P is equal to pressure. Pressure is equal to force by area. So m L raised to minus 1, T raised to minus 2. Okay. So we will get L square T raised to minus 2, m L raised to minus 3, divided by m L raised to minus 1, T raised to minus 2 is equal to m L raised to minus 1, T raised to minus 2, divided by m L raised to minus 1, T raised to minus 2, which is actually m raised to 0, L raised to 0, T raised to 0, this dimensionless. Dimensionless. This is dimensionless. Okay. Next one. In the relation y is equal to a sin omega t divided by x. Sorry. In the relation y is equal to s sin omega t minus kx, the dimension of k. What is the dimension of k? So we know, since we know that sin omega t minus kx is dimensionless. Okay, dimensionless. That means omega t is equal to kx. So we know that omega t is dimensionless and k is also dimensionless. So the dimension of k x, okay, so x is actually, so both are dimensional. So here actually that you know, omega t is equal to kx, so x is the distance, t is the time. So what will k you will get? K is equal to omega t by x. So what is omega? T raised to minus 1. Okay. Into t. Then x is nothing but distance. Okay. So what you will get? This will get cancelled. You get L raised to minus k is L raised to minus. Then only you will get x is L with k L raised to minus only you will get the dimensionless quantity. Okay, otherwise you will not get dimensionless. For this kx, k has to be dimensionless, L should be L raised to minus. Next is displacement y of a particle is given by y is equal to a cos omega t plus kx. Okay. So we have to find the dimensional formula for kx, which has the same dimension as that of whether it is a minus a by w, a by y, double t by a, y a by omega t. So here what happens? Omega t is equal to kx. That means this is cos omega t plus kx is dimensionless. So this omega to become this dimensionless, this is also w should be dimensionless, kx also should be dimensionless. Okay, so kx is dimensionless. Okay, so y by a is equal to cos omega t plus kx. Cos of omega t plus kx is dimensionless, therefore y by a is also dimensionless. Since y by a is dimensionless, a by y is dimensionless, a by b is also dimensionless. So kx is dimensionless, we got k is dimensionless, and a by b is dimensionless. The answer is 2, a by y. Suppose the refractive index of mu, mu is given by mu is equal to a plus b by lambda square, where a and b are constants and lambda is equal to wavelength. Okay. Given lambda is wavelength, a and b are constants. So what happened? We know that refractive index is dimensionless. Okay, it is a ratio. Refractive index is dimensionless. Since refractive index is dimensionless, b by lambda square is dimensionless. That means b is equal to lambda square, that is L square, nothing but area. So the dimension of b is area. Next, the modulus of velocity is dimensionally equivalent to, you know, the modulus of velocity is equal to stress by strain, and strain has no unit or no dimension. Strain has no dimensions, which is stress is equal to F by A is equal to nothing but pressure. So it is equivalent to pressure. Okay, so m L raised to minus 1 to raised to minus 2 is same as pressure. In the relation dy by dt is equal to 2 omega sine omega t plus theta, the dimensional formula for omega t plus theta is, we know that actually sine of omega t plus theta is equal to is dimensionless. Therefore, for this to be dimensionless, omega t plus theta should be dimensionless. So this is actually omega t plus theta is dimensionless. Next, dimensions of Stefan's constant. Stefan's constant. So we know that Stefan's constant is 5.670367 into 10 raised to 8 watts, meter raised to -2, K raised to -4. This is the unit for Stefan's constant. So watt is nothing but power. Therefore, it is equal to work by time into, okay, meter raised to -2, K raised to -4. Okay, temperature. So it will be m L square T raised to -2 by T into L square. Meter square is L raised to -2 into K raised to -4. So it will be m this L square and this L raised to -2 will get cancelled. Okay. So you will get m raised to 1, then T raised to -3, then K raised to -4. Okay, this is the dimension of Stefan's constant. With the usual notations, which one of the following does not represent the dimensions of time? Okay, which is not dimensions of time. We know that RC is time. We already discussed this in RC in time. Okay, that is this is time anyway. RC is time. Then omega XL reactant, inductive reactance is equal to omega L is equal to 2 pi FL. Okay, so omega L is equal to R. So omega L means actually omega is so L by R. L by R is L by R is omega. Okay, so L by R is R by omega. Sorry, 1 by omega. Okay, L by R is 1 by omega is equal to 1 by T raised to -1 is equal to T. So L by is R, L by R also T, that is also time. So RC is time, L by R also time. Now root LC. So from this we can find out L by R is equal to time. L is equal to RT. Okay. So C, now HC, capacitive reactance is equal to 1 by omega C. So which implies C is equal to 1 by omega XC. X is nothing but R. So it's equal to 1 by T raised to -1 R is equal to C. Okay. It's equal to T by R. So we got L is equal to RT, C is equal to T by R, which implies L into C LC. LC is equal to RT into T by R will get cancelled, we will get T square. Therefore, square root of LC is equal to nothing but T. So 1 by root of LC is equal to T raised to minus 1. Okay. So answer is, which is not T. This is equal to T raised to not 1 is equal to frequency. It is not 10. Okay. It is equal to frequency. Therefore, that fourth one, 1 by root LC is not, the dimension of 1 by root LC is not equal to 10. All those are 10 only. You can find out in another way also. You can find out the C and R. Okay, now we know that, but it is a lengthy way. You will take time. So I am showing you the easiest ways. So we know that R is equal to omega by Q. From this you can find out R. Then like that actually with the you can find out C also. Also, C is equal to Q by B. So from this also you can find out. Okay. R is equal to R is equal to, it's not correct, V by I. So we know that W by Q. So W by QI. From this you can find out R. Okay. Then from Q by V. So V actually already we know. What is V? V is equal to Q by W by Q. So Q square by W. From this also you can find out. Okay. Q by V, you can find capacitance. So from this, with both this actually you can find out the dimension. Then you can check each of this expression 1, 2, 3, 4. Or each of this you can check. From that also you can find out. But you know, as I told, the multiple choice questions actually, if you do all the things, it will take a lot of time for you. So you have to see the easiest way to come to a conclusion. Okay. Now, next question, the dimensions of K in the equation W is equal to half K x square, where W is work done, okay, and K is the extension in spring, okay. So we want to find the dimensions of K. We know that m L square T raised to minus 2 is equal to K x square. X is nothing but length. Therefore, Kx is equal to K L square. So K is equal to m T raised to minus 2. L square will get cancelled. Next one, the velocity v of a particle in an instant t is given by v is equal to at plus b t square. So we have to find out the dimensions of a and b. So here b is equal to at, which implies L t raised to minus 1 is equal to at. So we have a is equal to L t raised to minus 1 by t, that is L t raised to minus 2. Okay. So we got a. Similarly, again, L t raised to minus 1 is equal to b t square also. So b is equal to L t raised to minus 1 by t square, which is L t raised to minus 3. So b is L t raised to minus 3. Next one, if h is equal to Planck's constant, h by 2 pi will have the dimensions. So we know that given h is equal to Planck's constant. Okay, Planck's constant. Now h by 2 pi is having the dimensions same as h because 2 pi is a constant. But actually here if you see the answers, h is not given, Planck constant is given. Instead of velocity, momentum, energy, angular momentum and all, we know that the dimensions of h, Planck's constant and angular momentum are same. Okay, angular momentum are same. What's angular momentum? Angular momentum is equal to I omega. I is equal to moment of inertia. It is ml square t raised to minus 1. Okay, omega is t raised to minus 1. So h is also same, energy by frequency is equal to ml square t raised to minus 2 by t raised to minus 1. It is actually ml square t raised to minus 1. Okay, both have the same dimension. Therefore, we can say that answer is for angular momentum because it's having the same dimensions as the Planck's constant. Okay. Next one, the surface tension will have the same dimensions of. Okay, so surface tension we know it is force by length. Okay, surface tension is equal to force by length is equal to ml t raised to minus 2 by L is equal to m t raised to minus 2. Okay. Now, force, we know the next one we will check one by one. Spring constant. What is spring constant? We know that F is equal to minus kx. So, k is equal to F by x, that is ml t raised to minus 2 divided by L. It is actually m t raised to minus 2. Okay, again. So, it is same as the surface tension. Okay. Then impulse. Impulse is equal to force into time. Okay, delta at small time. So we can say m L t raised to minus 2 into t. So it is m L t raised to minus 1. So it is not the same. Then we have momentum. Momentum is m into v. M is m, v is L t raised to minus 1, this is ml t raised to minus 1. Okay. So it is having the same dimension as spring constant. Surface tension angle space, which is m t raised to minus 2. Okay. Now, the dimension, the equation of a wave is given by y is equal to a sin omega x by v minus k, where omega is angular velocity as we know and v is the linear velocity. So what is the dimension of k? That is the question. So we know that omega into x by v, but we'll take it like that. Actually, you have to find out k. X by v is equal to k. Okay, x by v is equal to k. But here also x by v into omega. Actually, this is dimensionless. X by v into x by v minus k into omega is dimensionless, which implies t raised to minus 1 into x is L, v is equal to, v is the velocity, L t raised to minus 1. Okay, L t raised to minus 1. Minus k is dimensionless. That means that means um, T L by, that is T raised to minus 1 into L and L get cancelled, 1 by T raised to minus 1 minus K is dimensionless. So 1 by T raised to minus 1 is actually T raised to minus 1 into T minus K is dimensionless. That means K is having same dimension as this one. So K is having the dimension of T. Is the dimension of T. Okay, so T have dimensions of K. So without that also we can say, since actually in the first place itself we can find out, because since sine omega x minus b minus k, the whole thing should be dimensionless. Therefore, x minus b minus k will have the dimension of t, because omega is t raised to minus 1. So both when multiplied, you will get t. So multiple, you will get the dimensionless quantity. Since this is t, x by b is t, and k is t. So k will have dimension t. This way also you can interpret this. If the units of length, mass, force are chosen, fundamental units, dimensions of change will be. So fundamental units are length, mass, and force. So we know force is equal to m into a. So mass is fundamental unit, no problem. Force is fundamental unit. Okay. Acceleration is not a fundamental unit. Okay. But length is a fundamental unit. So what we will do is equal to m into acceleration is equal to length by time square. Okay. Length by time square. So length is fundamental unit here. So we have to find the dimension of t. So t square is equal to m into L by f. Okay. So t is equal to m L by f raised to half, which means, yeah, m raised to half, L raised to half, f raised to minus half. If the speed of light is c, acceleration due to gravity g, pressure p, taken as fundamental quantities, the dimension of gravity constant g. So we are given fundamental quantities as speed of light c, acceleration due to gravity g, pressure p. We have to find out g, the dimension of g. Okay. We know that g is equal to fr square by m1 m2 is equal to, f is nothing but force by area is pressure, therefore pressure into area is force. So pressure into area. Okay. R square is actually distance. R square is something to distance square divided by m1 m2. Now let us see. C is velocity. Velocity is actually distance by time, which implies distance is equal to speed of light into t, time, c into t. Now we know acceleration is equal to v by t. Okay, v means c by t. Here v is c. C by T. So which implies time is equal to acceleration G. So C by G. Therefore, time distance is equal to CT is equal to C into C by G is equal to C square by G. Okay. Now we have F is equal to MA, which implies M is equal to F by A. F is equal to actually pressure into area. Okay. By acceleration is G. Already given. Okay. So area is distance square. So it is pressure into distance square divided by G. Okay. Now we have G is equal to pressure into area into distance square divided by M is pressure into pressure into area is pressure into distance square. Okay. Pressure into distance square. Sorry. See here, G is pressure into area in distance square by M. G is equal to pressure into area into distance square. Distance square by M1 is equal to pressure into area is distance square. Distance square, okay, into distance square again. Distance square divided by M1 is M is pressure into distance square by G. Okay. M is here M you can see pressure into distance square divided by G into pressure into distance square by G. Okay. Now what happens? Pressure into distance square. This will get cancelled. One distance square will get cancelled. So what we will get? We will get is equal to G square by pressure. So it will be G square p raised to minus 1. It will be G square p raised to minus 1. So let us see whether that answer is there or not. Yeah, the answer is not given. It is not given, but actually it is G square p raised to minus 1. You can write actually the C. C is actually 0. C raised to 0, G square p raised to minus 1. Okay. Here one mistake is there. It's not G raised to minus 2, it is G square. Okay, G square p raised to minus 1. Next question. If energy E, velocity V, and force F are taken as fundamental quantities, dimensions of mass, we have to find out. What the fundamental quantities? E, energy, okay, energy, then V, velocity, and F is the force. Then we have to find out mass. So we know F is equal to ma, which implies A is equal to F by A. Okay. So F by velocity is one quantity, therefore we can take P by T. Okay. Therefore it is called F energy, velocity, and force. The force is there, velocity is the T. T is here. Okay. So F is equal to V by T. So F into T by V. This is mass. Now T we have to find. The energy is force into distance. Okay. So is equal to force into distance is actually V by distance by time is velocity. So distance is velocity into time. Okay. Which implies time is equal to energy by V. Energy by V. F T is equal to, sorry, T is equal to Fs. Okay. F F into S energy by FB, sorry, E by FB, E by FB. So we know that M is equal to F into T by V is equal to F into E by F by V into E by FB. So we will get F and F will get cancelled. We will get E by V square. So it will be EV raised to minus 2. So mass is EV raised to minus 2. Next one. If area A, velocity V, and density rho are fundamental quantities, what is force? Okay, we know that F is equal to M into A. So we know density is equal to mass by volume. Okay, mass per volume. So mass per volume, then density here it's equal to M by velocity is actually L square into L. It's equal to M by area into square root of A, area. So M by A raised to 3 by 2. So mass is equal to rho into A 3 by 2, A raised to 3 by 2. Okay. Now we have velocity is equal to distance by time. So time is equal to distance by velocity. So it is root A. Okay, distance is actually L. So square root of A is L divided by V. Okay, so we got TRs. Now acceleration is velocity by time. So we can write acceleration V by time is root A by V. This is V square by root A. Hence, we have to find out F. Hence, what happened? F is equal to MA is equal to M. We already got here M. Equation 1 is rho a raised to 3 by 2 into acceleration a, equation 2, we have seen here acceleration, okay, that is v square by root a, that is a raised to minus half. So we got rho a raised to 3 by 2 minus half v square. It is nothing but rho v square a. This is the answer. Next question. A student writes escape velocity, okay, VA, as square root of g into m by r square. R is the radius, we know, m is mass, g is the constant, gravitational constant. So the question is whether it is dimensionally correct or not. Okay. So how will we know that g is equal to f r squared by m1 m2. Okay. This we know. So if we substitute the g here, what we will get? We will get g m square root of gm raised to half divided by r square is equal to so we will first consider the without square root. Okay, it is not without that. We will first check g. We know that okay. We will find out the now it is square root of gm by r square. Okay, so we'll consider without square root. So g into m by r square. So g we have taken f r square by m1 m2, okay, into m divided by r square. So r square will get cancelled. One of the m will get cancelled. So you will get f by m is equal to m l t raised to minus 2 by m. So we will get l t raised to minus 2. So square root of this figure, we will get actually square root of lt raised to minus 1, minus 2. So this is not, because escape velocity is actually l t raised to minus 1. So it is means square root of acceleration. Here what we got is actually velocity. So we got actually velocity is equal to square root of acceleration, which is dimensionally not correct. But you can, if the equation was gm by r, okay, square root of gm by r, then actually we will have got fr square by m1 m2 into m by r. So one r will get cancelled, one m will cancelled. What we will get? m ml t raised to minus 2 into l divided by m. So we will get actually l square t raised to minus 2. If you take the square root of this, we will get l t raised to minus 1, which is velocity. If it were like this, it would have been dimensionally correct. Okay, so both the cases we have discussed, gm by r square and gm by r, both we have discussed. Next question, if force F, length L, current I and time t taken as base quantities, the dimensions of epsilon 0. We know that epsilon 0 is equal to 1 by 4 pi f r square q1 q2. So 4 pi we can ignore. Then 1 by f L square. Okay, FL square. Then this F is fundamental quantity, L is fundamental quantity. Then I is fundamental quantity. Okay, time is fundamental quantity. S square T square. So it will be I square T square F raised to minus 1. Then L raised to minus 2. Okay. This will be the dimension. Next question. E, M and I. E, M and I. E is energy, M is mass, I is angular momentum. These are the gravitational constant, and G is gravitational constant. Then what is the dimension of E, EM, not I, J. Okay. E J square by M raised to 5 G square. This is what we wanted to find out. What are the dimensions? So we know that G is equal to FR square by M1 M2. So F is MLT raised to minus 2. R square is L square. So divided by M square, we will get M raised to minus 1 L cube T raised to minus 2. Okay. Now, if we substitute in this, what we will get is E is equal to energy ml square T raised to minus 2 into J. J is equal to I omega. Okay, I omega is, what is I omega? I omega is M L square T raised to minus 1. So J square is M L square T raised to minus 1 the whole square divided by M raised to 5. Then G we have got M raised to minus 1 L cube T raised to minus 2 the whole square. So what will we get? We will get M cube L raised to 6 T raised to minus 4 divided by M cube L raised to 6 T raised to minus 4, which is dimensionless. So what is the dimensionless quantity here? Angle. Okay, length is having dimensions. Okay, mass having dimensions, time having dimensions. So length, angle is the only thing having no dimensions. So the answer is 1, angle. If Planck's constant h, speed of Planck's constant is h, speed of light is c, universal gravitational constant is g, are the fundamental constant, which of the following combination have the dimensions of light? This is the question. Okay. So we have to find out the dimensions of length. See, the dimensions having the dimensions of length, the equations or that expression having dimensions of length out of the 4. We have to find out. So we know that h is equal to Planck's constant by E by F is equal to M L square T raised to minus 2 by T raised to minus 1 is equal to M L square T raised to minus 1. I am doing this again and again so that actually you will get a grasp of the things. You know, because seeing many times the same thing is being done, you will not forget this. That's why I'm doing it again and again. Otherwise, I can say, okay, you do it now as a homework or something. But actually, I'm doing it for your benefit. Okay. So we got h, then g is equal to f into r square by m1 m2 is equal to ml t raised to minus 2 into l square by m square. You will get m raised to minus 1 L cube T raised to minus 2. Okay. Now we know C is equal to LT raised to minus 1. Okay. Now, okay. Now, we have Hg by C cube whole raised to half is equal to H we know ml square T raised to minus 1, then G is m raised to minus 1, L cube T raised to minus 2, okay, divided by C cube. C is L raised to minus 1 T raised to minus 1, therefore L cube T raised to minus 3, the whole raised to half. Okay, what we are getting is actually L raised to 5 T raised to minus 3 by L cube T raised to minus 3, the whole raised to half, which is L. Okay, we will get L. We will get actually L square root of L square. That is L. We will get L. So that is the answer. We can do it in another fashion also. How we will do it actually? It is told that is L is proportional to then H raised to A, then G raised to B, or C raised to C. From this actually dimensions we can give here. Okay, then you can solve it. You will get actually A, B, and C. With that also you can find, you will get the same relation. Okay, you will get the same relation here also. Okay.